It's 1929, and a team of German scholars is working through a collection of old documents stored at Topkapi Palace Museum in Istanbul. Topkapi was the administrative heart of the Ottoman Empire for nearly 4 centuries. Its archives are enormous, sprawling, layered with centuries of accumulated records, correspondence, astronomical tables, and navigational charts. Most of what they're sorting through is familiar, expected, unremarkable. Then one of them unfolds a fragment of gazelle skin, roughly 90 by 65 centimetres, and stops. What they're looking at is a Portolan-style map. That's a type of nautical chart developed in the Mediterranean world in the late medieval period, characterised by a dense web of compass lines radiating outward from central nodes, coastlines drawn with remarkable precision for the era, and a focus on practical navigation rather than symbolic geography. This one is dated to the equivalent of 1513 in the Islamic calendar. It's signed by an Ottoman admiral and cartographer named Piri Reis, and it shows something that takes a moment to fully register. There's South America, there's the Atlantic Ocean, there are the coastlines of Europe and Africa drawn with the kind of detail you'd expect from a skilled navigator working in the early 16th century. But then your eye travels south, below the tip of South America, and there's something else, a large landmass curving along the bottom of the map, detailed, coastal, drawn with what looks like care and intention, not vague speculation. And according to the conventional history of exploration, that landmass should not be there. Not in 1513, not drawn that way. Antarctica wasn't officially discovered until 1820. The continent sits buried under an ice sheet that in places is more than 2 miles thick. Its true coastline, the actual rock and land beneath all that ice, wasn't mapped until the mid-20th century, using seismic surveys and sonar equipment that didn't exist until long after Piri Reis was dead. So the question that leapt out at those scholars in 1929, and that has never entirely gone away since, is this. What exactly is that southern landmass? How did it get onto this map? And why does it appear to show a coastline rather than a featureless wall of ice? Now, before we go any further, it's worth being clear about something, because this story tends to attract a particular kind of energy that isn't really warranted by the evidence. The Piri Reis Map is a real artifact. It's held at Topkapi Palace Museum today, and you can go look at it. Piri Reis was a real person, a serious and respected figure in the Ottoman naval world. The debate around this map is a real academic debate involving real cartographers, historians and geographers who disagree in good faith about what the evidence actually shows. There's no need to reach for ancient aliens or secret civilizations to find this genuinely strange and worth thinking about carefully. The strangeness is already built in. The core of the controversy is layered. First, there's the question of whether the southern landmass is Antarctica at all, or whether it might represent something else entirely, a misplaced South America, a speculative continent invented to balance the globe, a composite of earlier maps that had nothing to do with any real southern landmass. Second, if it does represent Antarctica, there's the question of how it could appear relatively ice-free or coastline-defined, in a way that seems to correspond more closely to the subglacial terrain than to the ice-covered surface. Third, there's the question of sources. Piri Reis himself claimed he was working from much older maps, some of which dated back to the era of Alexander the Great. What were those sources, where did they come from, and what did they actually show? These questions have attracted serious scholarly attention and serious scholarly disagreement for nearly a century now. Some researchers have argued that the correspondence between the southern landmass on the Piri Reis map and the actual coastline of Antarctica beneath the ice is too precise to be coincidental, and implies the existence of a now-lost source map made before the continent was glaciated. Others argue the resemblance is superficial at best. the product of wishful pattern matching applied to a map that was always a patchwork of sources with varying reliability and distorted by the projection problems that affected every cartographer of the period. Both sides have made specific, technical, checkable claims. That's what makes this worth taking seriously rather than just dismissing or uncritically accepting. What we can say with confidence is that the rediscovery of this map in 1929 set off a chain of questions that cartographers and historians are still working through today. The map was brought to wider public attention in the 1950s and 1960s when a geography professor in New Hampshire named Charles Hapgood began applying systematic analysis to it, comparing the positions of landmarks on the map to their actual coordinates, and arguing that the correspondence was too good to be explained by conventional 16th century cartography alone. His work attracted the attention of the United States Air Force Strategic Air Command, which is one of the more unusual footnotes in the history of cartography. We'll get to all of that. But start with the artifact itself, a fragment of a map on a piece of animal skin found in a palace archive in Istanbul, showing a world that the 16th century had every reason not to know about yet. That image alone is worth sitting with for a moment. Not because it proves anything, not because it overturns everything we know about the history of exploration, but because it's genuinely mysterious, and genuine mysteries deserve careful, patient attention rather than quick answers in either direction. By the way, if you're listening to this and wondering where you are in the world right now, I'm curious too. Drop a comment telling me where you're listening from and what time it is there. It's one of my favourite things about making these. Someone in Tokyo at 3 a.m, someone in London having breakfast, someone in Buenos Aires on a long commute. The geography of who's awake and listening is its own kind of map, and if you want to follow along somewhere without ads or background music, we're on Spotify now. The link is in the description, and honestly, following there is one of the best ways to support what we're doing here. The story of the Piri Reis Map is ultimately a story about the edges of knowledge, about what it means when a document seems to show more than it should, about how we decide what evidence counts, who gets to interpret it, and how we hold open questions without forcing them into premature conclusions. It's also a story about transmission, about how knowledge travels through time, sometimes degrading, sometimes surviving in fragmentary form, sometimes arriving in ways we don't fully understand. A map drawn in 1513, using sources that may stretch back centuries before that, found in a palace archive in 1929, still generating serious scholarly disagreement today. That's a long chain of transmission, and somewhere in that chain there are answers we haven't found yet. So let's follow the chain. Let's look carefully at what the map actually shows, who Piri Reis was, what he claimed about his sources, what the best arguments on each side actually say, and what the unresolved questions look like when you hold them up to the light. Because whether or not this map shows Antarctica, and whether or not the answer to that question turns out to be the one some people hope for, the process of asking it rigorously is worth every minute. The object itself is important to understand before anything else, because a lot of the debate around this map collapses into confusion when people aren't clear on what they're actually looking at. What survives from 1513 is a fragment, not a complete world map, not a grand cosmographical statement meant to represent the entire known world in systematic fashion. What you're holding in your mind when you think about the Piri Reis Map is a piece of gazelle skin parchment roughly the size of a large poster, about 90 by 65 centimetres, painted in the style of a Portolan chart. And that style matters, because Portolan charts were a specific tradition with specific strengths and specific limitations, and understanding that tradition tells you a great deal about what you're looking at and what you're not. Portolan charts emerged in the Mediterranean world sometime in the late 13th or early 14th century, and they were built around a single practical priority: getting ships from one port to another without running aground. They weren't meant to represent the whole globe in philosophical terms. They were navigational tools, and everything about their design reflects that purpose. The most distinctive feature is the network of rhumb lines, straight lines radiating outward from a series of compass rose nodes scattered across the chart's surface. These lines represent compass bearings, the directions a sailor would actually sail to get from here to there. The coastlines on a Portolan chart tend to be drawn with remarkable fidelity to real geography, particularly in regions that had been extensively sailed and surveyed by Mediterranean and Iberian navigators. The harbours, headlands, river mouths, and bays that a ship captain needed to recognise are often rendered with a precision that still surprises people when they compare these old charts to modern maps. What Portolan charts are not is mathematically rigorous in the way a modern map projection is. They weren't drawn on a calculated grid that correctly accounts for the curvature of the Earth across large distances. They accumulate distortion as you move away from the regions of most intense navigational experience. Coastlines close to the Mediterranean and the Iberian Atlantic are often quite accurate. Regions farther afield, drawn from second-hand accounts, older manuscripts or educated inference, can drift significantly in shape, scale, and position. The Piri Reis fragment covers the Atlantic world as understood in 1513. On the right side of the parchment you can identify the western coastlines of Europe and North Africa, drawn with the confident detail you would expect from an Ottoman navigator working in the early 16th century Iberian tradition. Scattered across the middle of the Atlantic are the islands that Portuguese and Spanish sailors had been working with for decades by that point. The Azores, the Canary Islands, the Cape Verde Islands, islands in the Caribbean that had only recently entered European awareness. The coast of West Africa sweeps down the right-hand side, and running down the left side you can make out the eastern coast of what is clearly South America, specifically the bulge of Brazil, rendered with reasonable fidelity to the actual shape of the continent as we know it today. Then there is the feature at the bottom. Below the tip of South America, the map extends into a large landmass that curves across the lower portion of the parchment. It's drawn with apparent coastal detail, with bays and peninsulas and what look like river mouths. It sits connected to, or very close to, South America's southern end, separated by what may be intended as a strait. Its shape, the way it curves eastward, the way its northern edge is drawn, is what has generated so much argument. And the argument isn't about whether something is there. It clearly is. The argument is about what it represents, how it got onto the map, and whether its correspondence to any real geography is precise, approximate, or essentially coincidental. Running through the map and around its margins are inscriptions in Ottoman Turkish. These are not decorative, they are substantive. Piri Reis wrote explanatory notes directly onto the parchment, identifying regions, describing the creatures and peoples rumoured to inhabit them, and crucially explaining where he got his information. He names specific source materials. He refers to older maps. He mentions charts that had come from Spanish navigators, including one that he claims was captured from a sailor who had sailed with Columbus. He references Ptolemaic geography, and he refers to a group of what he calls ancient maps, sources of uncertain origin that he incorporated alongside the more recent material. These marginalia are among the primary pieces of evidence in every serious analysis of this map, because they're the closest thing we have to Piri Reis explaining himself in his own words. This is the object, then, a working navigational chart in a well-understood tradition, drawn from multiple sources of varying age and reliability, covering a specific portion of the world with genuinely impressive accuracy in some areas and significant uncertainty in others, featuring a labelled and detailed southern landmass whose identity remains contested, and accompanied by written notes that tell us something, though not everything, about where it came from. That's what the Piri Reis Map actually is. Not a miracle, not a fraud, a document with all the complexity that implies. To understand why this one fragmentary chart looks the way it does, you have to meet the man whose name is written on it, and the world he was operating inside. Because Piri Reis wasn't a monk in a candlelit cell sketching phantoms from imagination. He was an officer in one of the most formidable maritime powers on Earth, working at a moment when the map of the Atlantic was literally changing every year. His full name was Ahmed Muhyiddin Piri, but history remembers him by his title, Piri Reis. Reis meaning captain, commander, admiral. He was born probably in the 1460s or early 1470s in Gallipoli, a naval base on the Dardanelles that looked out toward the Aegean, and beyond that the Mediterranean. From early on his life was tied to ships and to war. He served under his famous uncle Kemal Reis, an Ottoman corsair-turned-admiral who raided Spanish and Italian coasts, escorted Muslim and Jewish refugees out of Iberia after 1492, and fought Venetian fleets for control of trade routes. Piri grew up in that world, the smell of pitch and salt, the clatter of oars, the brutal arithmetic of distance, wind and coastline. By the time he was drawing charts, he was not a detached theorist. He was a practitioner, someone who had watched what happened when a harbour was misplaced on a chart or a shoal was left off entirely. In the late 15th and early 16th centuries, an error in longitude wasn't an abstract problem. It was a broken hull and drowned men. The timing of his career matters. The Ottomans had captured Constantinople in 1453 and were pushing deep into the eastern Mediterranean, the Red Sea, and later the Indian Ocean. At exactly the same time, their Christian rivals on the western edge of Europe, Portugal and Spain, were pushing out into the Atlantic. In 1488, Bartolomeu Dias rounded the Cape of Good Hope. In 1492, Columbus crossed to the Caribbean. In 1498, Vasco da Gama reached India by sea. The planet's coastlines were suddenly not theoretical. They were battlefields. From the Ottoman point of view, this was strategic shock. Trade that had once flowed through the eastern Mediterranean and the Red Sea was starting to leak around Africa into the hands of the Portuguese. Spanish fleets were bringing silver and unfamiliar products from a new world that barely had a place in older Islamic and European geographies. The question for an Ottoman admiral was not whether these voyages were philosophically interesting. The question was, where exactly are these routes, these islands, these capes? How close are they to our coasts, our allies, our shipping lanes? That's the environment Piri was working in when he drew the 1513 map, an empire that understood perfectly well that knowledge of coasts and currents was power, an officer corps that was beginning to think not just in terms of the Aegean or the Levant, but in terms of oceans and global competition. In that era, sailors did not acquire geographic knowledge by sitting in libraries reading world histories. They built it out of experience, rumour, and plunder. A navigator like Piri would spend years accumulating mental and physical fragments, the exact shape of a headland you'd only recognise at dawn if you'd seen it before, the set of bearings that got you safely across a tricky stretch of open water, a scrap of parchment taken from a captured Portuguese carrack, a rough sketch traded in a North African port for coin or favours. Captured charts were especially important. The Iberian powers guarded their cartographic secrets as stately assets. Portuguese pilots' rutters, written sailing directions, were treated as classified material. Spanish world charts, the Padrón reel, were kept under tight control. If an Ottoman squadron intercepted a ship carrying one of those documents, that paper became gold. It might be copied, adapted, folded into the empire's own archives in Istanbul. There were also the pilots themselves. A navigator captured in battle or convinced to change loyalties could be debriefed. What route did you sail? How many days from here to that island at this wind? What did the coastline look like at the entrance to this bay? A skilled interrogator could turn a human memory into a usable chart, especially if he already had his own sailing experience to cross-check the story. On top of that, there were the everyday hubs of information, trading ports from Alexandria to Tunis to Seville, where news travelled faster than ships. Merchants, pirates, diplomats, and fishermen all carried fragments of geography in their heads. State archives collected and tried in their own way to systematize this mess. Rolling together older Islamic works based on Ptolemaic ideas, medieval Portolan traditions, and the staggering new discoveries pouring out of Iberian voyages. Piri didn't just draw one map and vanish. He went on to produce one of the most important works of practical navigation of his time, the Kitab al-Bahriyeh, the Book of Navigation. First compiled in the 1520s and later expanded, it was essentially a mariner's manual for the Mediterranean. It combined detailed coastal charts with pages of description: where to anchor, what winds to expect in different seasons, which channels were hazardous, how to recognize a harbour from offshore. It wasn't a work of abstract geography. It was a tool for people whose lives depended on those pages being right. That book shows you how Piri thought. He wasn't trying to discover the shape of the world for philosophy's sake. He was trying to give captains something they could steer by. When you look at the 1513 map with that in mind, including its strange southern landmass, you're not looking at a mystical revelation. You're looking at a working officer trying to synthesize everything available to him into a coherent sailing chart. So why an Atlantic map at all, and why then? From an Ottoman perspective, in 1513 the Atlantic was no longer some distant, irrelevant fringe. Portuguese fleets surrounding Africa threatened Red Sea and Indian Ocean routes that the Ottomans were moving to control. Spanish expansion across the ocean might, in time, intersect with North African and West African spaces where Ottoman influence or interest could grow. You needed to know, how wide really is this ocean? Where are the winds favourable? How do the new lands relate to the old coasts of Africa and Europe that your pilots already knew intimately? An Atlantic map drawn in Istanbul or Gallipoli in 1513 is best understood as strategic intelligence. Piri himself says in his inscriptions that he relied on about 20 charts and mappae mundi, including Arabic maps, maps drawn in the time of Alexander, and a map drawn by Columbus. Whether we take each of those claims literally or see some of them as rhetorical flourishes, the pattern is clear. He was aggregating. He did this aggregation under severe constraints. Nobody in 1513 had a satellite view. Nobody had flown over a coastline to see its overall shape. Latitude could be estimated reasonably well with instruments like the astrolabe and cross-staff, but longitude, east-west position, was almost impossible to fix accurately at sea. Sailors relied on dead reckoning, counting days and estimating speeds, correcting with whatever landfalls they could find. The result, worldwide, was a geography where north-south placement might be roughly right, but east-west distances stretched and compressed unpredictably. Coasts that were locally accurate could be stitched together in ways that distorted their true global relationships. Add to this the basic fact that exploration was uneven. By 1513, Portuguese pilots knew the outline of West Africa fairly well. Spanish pilots were only just beginning to trace the Caribbean and the Americas. Vast sections of the globe were still rumour, extrapolation, or blank. Piri Reis was working at that frontier between knowledge and speculation. He had precise information for some stretches of coast, hazy reports for others, and a framework inherited from older geographers that didn't necessarily match what the new voyages were revealing. In that gap, interesting things can happen. Coastlines can be doubled, shifted, rotated. Unknown southern spaces can be filled in with land masses whose status, memory, myth or mistake, is hard to untangle 5 centuries later. That's the man and the world behind the parchment. An Ottoman admiral with practical experience, operating in a fiercely competitive age of discovery, assembling a composite picture of the Atlantic out of charts, prisoners, port gossip, and older scholarship, all constrained by the very real limits of 16th century navigation. When he tells us in his own notes what sources he used for that mysterious southern land, we have to take that seriously, and that means looking closely at those sources and at what he thought he was putting on the page. If you lean in close to the surviving fragment of the 1513 chart, past the cracks and stains, you can still read Piri's own handwriting along the coasts. These are his marginal notes, little windows into how he built the map and what he thought about it. And he is very clear about one thing. This was not a work of solitary inspiration. It was a compilation. In one famous inscription, he says he made it by reducing about 20 charts and mappae mundi to a single form. Some were Arabic, some were Indian, by which he probably meant from the wider Indian Ocean and Indo-Persian world. Some, he says, were maps drawn in the time of Alexander, and one, he tells us explicitly, was a chart drawn by Columbus in the western region. Those phrases have launched almost as many theories as the map itself. Start with the Alexander line, because that's the one people love to run with. In the marginalia near the western Atlantic, Piri describes one of his sources as a map, drawn in the time of Iskender, Alexander the Great. He doesn't say where this map was kept. He doesn't say who drew it. He doesn't even say it was Greek. He just drops this tantalizing reference, then moves on. Later writers, especially in the 20th century, took that phrase and connected it to the most romantic symbol of lost ancient knowledge they could think of, the Library of Alexandria. You'll see the argument in books and documentaries. Piri must have had access to charts descending from some Hellenistic master map. Those charts must have been preserved in Alexandria. Therefore the 1513 map secretly encodes data from a pre-classical, maybe even Ice Age survey of the world. Notice what had to happen for that story to form. One short phrase in Ottoman Turkish, drawn in the time of Alexander, becomes a literal Hellenistic original. That original is then placed without evidence in a specific institution that had already been destroyed more than 1,000 years before Piri was born. From there, you can spin almost anything you want. But if you stick to what the marginalia actually says, the picture is both more modest and more interesting. Drawn in the time of Alexander could mean a lot of things in early 16th century Ottoman discourse. The time of Alexander was sometimes a kind of shorthand for the ancient world as a whole, a legendary era of conquest stretching from Greece to India. Islamic geographers had long woven Alexander into their own cosmologies. Medieval Arabic tales about Dhul Qarnayn, the two-horned one, blend Greek and Persian traditions. When an Ottoman admiral in 1513 mentions maps from Alexander's time, he might simply be signalling very old Greek-derived material, not a specific library shelf. We also know that by Piri's day, a lot of classical geography had already passed through multiple layers of translation and adaptation. Ptolemy's 2nd century Geographia had survived in the Greek East, been translated into Arabic, commented on, and critiqued by scholars in Baghdad and Damascus, then made its way back into Latin Europe in the 15th century. Along the way, coordinates were copied, amended, sometimes corrected based on travellers' reports. Coastlines drifted, names shifted. So when Piri talks about using maps rooted in that older tradition, it's entirely plausible he's referring to charts that ultimately descend from some Greco-Roman world picture, filtered through centuries of Islamic scholarship. They might have reached him via Arabic Portolan charts, via scholars in Cairo or Istanbul, or via Italian intermediaries who had been working with Ptolemaic projections since the age of print began. Then there are the more recent and easier to trace sources he names. He explicitly mentions a chart by Columbus. That alone tells you how porous supposedly secret information could be. Columbus's original charts are lost, but copies, notes, and derivative portolans circulated. Spanish pilots carried mental and physical maps. Some defected to Portugal, others were captured by French or Portuguese privateers. From there, the maps could be seized again by North African corsairs or Ottoman squadrons and end up in a dockyard office in Gallipoli. Piri even recounts in one of his marginal notes that his uncle Kemal Reis had taken charts from a captured Spanish sailor who had sailed with Columbus. He's not just boasting, he's giving you a genealogy. The western coasts on his map, he says, reflect not just rumour, but a map by Columbus, obtained by force and then copied. He also tells us he used Portuguese sea charts. That fits perfectly with what we know from other records. By 1513, the Portuguese had mapped the West African coast in detail and had at least a rough idea of Brazil's outline and the bulge of South America. Their pilots guarded that data fiercely. Capturing a Portuguese Carta de Marea was like capturing a warship. Finally, he mentions Arabic and Indian maps. The Indian Ocean world had its own robust cartographic and sailing traditions long before the Portuguese arrived. Pilot books with bearings and distances, coastal sketches, knowledge of monsoon patterns and currents. Islamic mariners had been sailing from the Red Sea to India, to Southeast Asia, and down the East African coast for centuries. Some of that knowledge was codified in written rutters. Some was encoded in charts Piri could have seen in Cairo, Jeddah, or Istanbul. Put all of that together, and you have a realistic, historically grounded palette of sources. Iberian portolan charts, possibly including material derived from Columbus, Portuguese rutters and world maps, Arabic and Indo-Persian sailing charts, an older Ptolemaic-influenced Mappe Mundi that Piri, in his own cultural idiom, described as dating back to the time of Alexander. Now comes the harder part. How those sources interact when you try to compress them into one picture. Imagine laying 20 different maps of the Atlantic on a table. One uses a Ptolemaic grid with a too small Earth and a clipped-off southern hemisphere. One is a Mediterranean-style portolan, designed to be accurate for coasts and bearings near the centre, but increasingly distorted as you head west. One is a Portuguese chart of Africa, with good latitudes but guesswork longitudes. One is a rough copy of a Columbus map that misplaces islands, but nails a few particular capes. Others are schematic world pictures with a massive southern continent drawn in partly for balance, partly for inherited cosmology. Your task is to reduce them to a single chart. You adjust coastlines so known capes line up. You compromise where they disagree. You decide which latitudes to trust, which bearings feel right from your own sailing experience. You may rotate a coastline slightly so that it fits the wind and current patterns you know. You might stretch or compress distances to reconcile the number of sailing days between ports reported in a rutter with the positions shown in an older Mappamundi. Every time you redraw a line, it drifts a little from its source. Every time you shift a cape to make it join another coastline, you introduce a distortion. Over multiple generations of copying and improving, those distortions don't just add up. They can fold back on themselves. Two different coasts from two different latitudes can end up stitched together as if they were parts of one continuous shoreline. An island can become a peninsula. A speculative southern land inserted by one cartographer to balance the globe can, in the hands of another, be adjusted, rotated, and interpreted as a real surveyed continent. That's the chain Piri is standing at the end of. He has access to fresh Iberian data that is roughly right for the New World and Africa, mixed with older, sometimes wildly wrong assumptions about the extent of Asia and the existence of southern lands. He has local precision near coasts pilots actually sail, and big-picture fantasies in blank regions nobody has seen. He has his own practical judgment, honed at sea, and a set of inherited authorities that carry the weight of antiquity. When you look at that strange southern landmass on his map, the crucial question becomes, is there any plausible way, through this kind of copying chain, that a real memory of far southern coasts could have survived? Could a chart rooted in Hellenistic or even earlier exploration, preserved through Arabic geography, have smuggled some fragment of Antarctica, or of some ice-free coastline, into Piri's working archive? Or are we seeing something else entirely? A composite of misaligned South American coasts, rotated projections, and the long shadow of a hypothetical terra australis that had haunted world maps since classical times? Piri's own notes don't answer that. They just tell us where he thought his information came from. Columbus, the Portuguese, Arabic and Indian pilots, and venerable maps he linked in his mind to Alexander's age. The mystery lives in the gap between those sources and the shape he finally drew at the bottom of his page. To even ask whether that southern land could be Antarctica, you have to set it against what we actually know about when humans first reached the frozen continent. On the conventional timeline, Antarctica is not an ancient, half-remembered shore. It's a very recent arrival in human awareness. European ships had been feeling their way south into higher and higher latitudes since the Age of Discovery began. By the late 18th century, Captain James Cook had circled the globe between about 60 and 71 degrees south, crossing the Antarctic Circle 3 times. He sailed through fields of pack ice, saw icebergs the size of towns, and concluded that if a southern continent existed, it was locked behind a solid, compact body of ice, extending quite to the pole. No coasts, no harbours, no bare rock, just ice. The first sightings of what we would now call the Antarctic mainland come from the early 19th century, and they're messy, contested and ambiguous. On January 27, 1820, a Russian expedition under Fabian Gottlieb von Bellingshausen and Mikhail Lazarev reported a continuous ice shore at about 69 degrees 21 minutes south off what we now call the Princess Martha coast. Whether they actually saw the continent or just massive shelf ice remains debated, but their logbooks are one candidate for the first. 10 days later, on February 7, 1820, Irish navigator Edward Bransfield, sailing for the British Admiralty, charted the northern tip of the Antarctic Peninsula. His expedition recorded and sketched land that we would now agree is truly part of continental Antarctica. In November that same year, American sealer Nathaniel Palmer reached the South Shetland and Palmer archipelagos and reported land to the south. Some American accounts later promoted him as the discoverer of the continent, which did not help the already tangled national rivalries. Then, over the next 2 decades, you get a slow tightening of the net. Sealers and whalers push toward the pack ice in search of new grounds. The French explorer Jules Dumont d'Urville names a daily land in 1840. The United States exploring expedition under Charles Wilkes in 1838 to 1842 claims to have traced a continental coastline along what is now Wilkes Land, though later critics would argue about how much of what they saw was grounded land and how much was floating ice. Only by the mid-19th century does a rough outline of Antarctica as a single large continent begin to coalesce in scientific circles. Even then, it is an outline glimpsed through fog and ice. Disconnected coastal segments, guessed at connections, immense blank spaces. So if you're sticking with mainstream history, the idea that anyone in antiquity knew the detailed shape of an Antarctic shoreline is a non-starter. Nobody, as far as we can tell from written records, from archaeology, or from the history of navigation, had the ships, the incentive, or the sheer stubbornness to push through the roaring 40s, the furious 50s, and into ice-choked waters thousands of miles from any known land. And that's before you even bring in the ice. Antarctica today is not just cold, it is buried. The ice sheet that covers the continent averages more than 1.5 kilometers thick. In some places, like East Antarctica, it sinks past 3 kilometers, Only a few mountain chains and coastal nunataks poke through as exposed rock. The rest of the coast we see is often not land at all, but floating ice shelves, vast, thick tongues of glacial ice extending out over the ocean. Now, imagine trying to make an accurate coastal survey of that. Even with 20th century technology, it was extremely hard. For much of the modern era, charting Antarctic coasts meant sailing through treacherous belts of pack ice, landing where you could, and taking rough bearings. Visibility was often terrible. Compass readings could be distorted by proximity to the magnetic pole. Huge stretches of shoreline were assumed or interpolated. To map the land beneath the ice, the real coastline, the drowned valleys, the buried bays, required tools nobody had before the mid-1900s. Seismic sounding, gravimetry, radar from aircraft and satellites, and dense networks of measurements to plug into glaciological models. This is where the ice-free coast claim starts to sound extraordinary. The argument, as it's usually presented, runs something like this. The southern landmass on the Piri Reis Map, and on a few later 16th century maps, looks less like a generic terra australis, and more like specific parts of Antarctica, as they would appear without their ice cover. Depending on who you're reading, the resemblance is said to be strongest either to Queen Maud Land along the coast of East Antarctica, or to stretches of the Antarctic Peninsula and its off-lying islands. In Hapgood's version, and in many of the books that followed him, the emphasis falls on Queen Maud Land, the sector between roughly 20 degrees west and 45 degrees east. If you strip away the ice using mid-20th century reconstructions, you get a mountainous, indented coastline with bays, peninsulas and inlets. Advocates will trace the outline of that reconstructed coast, lay it over a redrawn version of Piri's southern shore, and argue that the match is too good to be coincidence. In other tellings, the southern land on Piri's chart is rotated or reprojected to line up with the Antarctic Peninsula, the finger of land pointing towards South America and nearby coasts. The resemblance in that case is said to hinge on the way a long narrow peninsula hooks northward and then kinks back, and on clusters of islands off the tip. But notice what's actually being compared. On one side, you have inked lines on a 16th century parchment. Those lines have already passed through multiple generations of copying and distortion, and they sit on a projection that's not fully understood. The map's grid is not a simple modern latitude-longitude net. It's some hybrid of Portolan rumline logic and inherited cosmology. Coastlines are stylized, bays are exaggerated or smoothed, distances stretch and compress with no mathematical consistency once you move away from familiar sailing grounds. On the other side, you have modern coastlines, and not just the coastlines you see on a satellite photo today. For the ice-free Antarctica argument, you're often looking at products like the Bedmap or Bedmap 2 reconstructions, painstaking attempts to infer what the bedrock topography under the ice would look like if all that ice were removed and sea level adjusted accordingly. Those reconstructions rest on glaciology. Scientists send radio waves down through the ice, measure the return times, and combine that with seismic profiles, gravity anomalies, and ice flow models to build a best guess map of the buried landscape. Early versions of these subglacial charts from the 1950s and 60s were coarse. Data coverage was sparse, especially in East Antarctica. Whole regions of known coast were essentially smoothed over interpolations between flight lines. So when someone in the 20th century says, look, this 16th century map matches an ice-free Antarctic coastline, they're really saying, this hand-drawn shoreline bears a family resemblance to a modern, model-dependent reconstruction of what we now think the bedrock coastline might look like under several kilometres of ice, according to the data we've managed to collect so far. There's a lot of room for pareidolia in that gap, the human tendency to see meaningful shapes in fuzzy data. It's the same impulse that finds faces in clouds, or animals in star patterns. Given a suggestive contour and a desire to see Antarctica, you can often persuade your mind that the fit is better than it really is. Glaciology also raises a deeper issue. When proponents say ice-free Antarctica, what exactly do they mean? No significant part of continental Antarctica has been free of ice in the last several million years, in the sense of being a temperate, green, survey-ready shoreline. There have been fluctuations, ice sheets thinning and thickening with glacial cycles, shelves collapsing and reforming, local retreat in certain marine basins. Some coastal mountains and high ridges have stayed largely ice-free as nunataks. But the picture of a broad, open, navigable, habitable Antarctic coast during the last 12,000 years is completely at odds with current paleoclimate evidence. When glaciologists talk about ice-free conditions in deep time, they often mean tens of millions of years ago, in the Eocene or earlier, when global climates were radically different and humans didn't exist. Or they mean localized deglaciation along a fjord, not the collapse of the entire East Antarctic ice sheet. So an ice-free coastline, in the strong sense that the Piri Reis Antarctica theory requires, a perimeter of bare rock inviting careful survey, is not something our species is thought to have ever seen, and yet, when you stare at that southern land on the 1513 map, the resemblance can feel uncanny. It doesn't look quite like a generic ornamental Terra Australis in the medieval style. It kisses and curves and hooks in ways that seem, at first glance, more specific. Is that just because we're overlaying our modern mental picture of Antarctica onto anything that roughly matches? Is it a coincidence born from the way distorted South American coasts, rotated and stitched together, end up mimicking a polar land? Is it simply that when you juggle enough coastlines and projections, some of them are bound to look similar to something else? Or is there a sliver of a chance, however small, that some older geographic knowledge, however fragmentary or garbled, found its way into Piri's source material and then into his drawing of the world's underside? At this stage in the story, we can't answer that. We can only say that the comparison isn't as straightforward as old map matches modern Antarctica. It's shapes on parchment versus shapes in models, both filtered through human imagination. To make any headway, we have to look more closely at what Piri actually drew, the placement of that southern land relative to recognised coasts, the way its bays and capes line up, or fail to line up, with known South American features and the internal logic of the map's projection. When you zoom into that level, some of the magic dissolves, but some of the weirdness remains. So let's do the unromantic thing and actually walk along that southern shore. Start with what we know. The recognisable parts of the Piri Reis Map cluster in the north, the western coasts of Europe and Africa, the Atlantic dotted with islands, and then curving down a surprisingly decent attempt at eastern South America. The land we're interested in sits beneath all of that, curving from under Brazil and sweeping eastward across the bottom of the parchment. If you trace it with your finger, it feels big. Bigger than South America, bigger than Africa. Part of that is just how the map is laid out. This isn't a modern projection centred on the equator with a neat grid. It's drawn like a Portoland chart on steroids, built around compass roses and wind directions, optimised for sailors, not for geographers. As you move away from the familiar Atlantic sailing lanes, scale begins to wobble. Distances stretch or compress in ways that make sense if you're thinking in days at sea, not in kilometres. Down near the bottom, that wobble is extreme. Latitude lines, where they exist at all, are approximate. The coastlines are squeezed to fit the parchment and to accommodate decorative elements. So the southern landmass looks oversized, partly because it's living in the funhouse mirror zone of the map. Even so, its outline is specific enough that people have tried to give it a name. The most conservative identification, and the one favoured by many historical cartographers, is that this continent is simply an extension of South America. In early 16th century European maps, the southern reaches of the New World were not yet nailed down. Magellan's circumnavigation was still a few years in the future. Nobody from the Mediterranean world had sailed far down the Pacific side of South America, so it was absolutely reasonable to imagine that the land Piri labels as Brazil might curve further east and south, perhaps even joining up with an as yet unknown southern continent. On this reading, the land under South America isn't a separate piece at all. It's the hypothetical continuation of the same landmass, drawn larger and more curved because that's what the cosmological picture of the time suggested. A balance between north and south, land answering land across the equator. That leads to the second common interpretation, that we're looking at a version of Terra Australis, the great southern continent that had been haunting European and Islamic geography for centuries. Long before anyone had sailed into the high southern latitudes, scholars argued that there must be a vast land in the south to counterbalance the weight of land in the north. You find this idea in Ptolemaic tradition, in medieval Mappae Mundi, and in early Renaissance globes. It's not based on observation, it's based on symmetry. Under that framework, Piri's southern land is speculative. It exists not because someone charted its coasts, but because the world view of the time almost demanded that something be there. The third identification, of course, is the controversial one, that this is the northern fringe of Antarctica, or at least that it incorporates fragments of a more accurate southern coastline than anyone in 1513 should have had. If you look at reproductions that isolate just that southern arc and strip away the labels, you can see why people are tempted. There are inlets and bulges, a long sweeping curve, a hooked projection, a knot of islands off one edge. With the right mental rotation, it's easy to start matching these to Queen Maud Land, or to the Antarctic Peninsula pointing toward South America. But here's where cartographic reality starts to bite. 16th century mapmakers didn't draw coasts the way we do. They didn't have aerial views or satellite imagery. A shoreline for them was a series of discrete experiences, anchorages, headlands seen from a ship's deck, bearings taken with crude instruments, distances estimated by dead reckoning. When those notes were turned into a continuous line on a map, a lot of smoothing happened. Straight stretches of coast would be idealized. Bays and fjords that sailors never entered might vanish completely. A maze of islands and inlets could be compressed into a single rounded bay with a few token islands sketched in. Where information was thin, artists leaned on convention. Generic scalloped curves for coasts, cartoon-like mountain chains marching inland, rivers that sprang from central hills and dutifully flowed to the sea. Look closely at Piri's southern land and you see that language at work. The shoreline is smooth, almost too smooth, with big regular arcs. The interior is studded with neat rows of mountains, drawn in the same symbolic style you see in North Africa or in Anatolia on other contemporary maps. Those mountains don't correspond to surveyed ranges. They're a way of saying, this is land and it's not flat. That's important, because when modern eyes go hunting for Antarctica in those lines, they're often matching against generalized shapes that could belong to any number of large, roughly curved coasts. Now add another layer of complication, projection and rotation. If you take any irregular coastline and allow yourself to rotate it, stretch it or compress it, you can make it resemble a surprising number of other coasts. Cartographers know this all too well. A map centered on the equator and drawn with a cylindrical projection will make Greenland look enormous. Switch to a polar azimuthal projection, and the Arctic Ocean becomes a ring round the pole. The Piri Reis Map isn't drawn on a simple projection we can fully reconstruct. It appears to mix a roughly equidistant grid for latitude with Portolan-style rhumb lines radiating from compass roses, and perhaps with inherited Ptolemaic longitudes patched in from older world maps. As you move southward, the geometry distorts in ways that are not mathematically consistent by modern standards. So when researchers in the 20th century took Piri's southern coastline and digitally, or in Hapgood's time manually, rotated it, scaled it, and reprojected it onto a modern polar grid, they were doing something powerful but also dangerous. If you're allowed to tilt the map, slide the coast northward, compress one part and expand another, you can often coax a superficial match with some stretch of modern Antarctic shore. This doesn't automatically make the match meaningless. It just means that it looks similar after we rotate and stretch it, is weaker evidence than it might sound at first hearing. In a world of curving coasts and flexible projections, many outlines will overlap if you give yourself enough freedom to manipulate them. Underlying all of this are the basic constraints that Piri and his sources lived under. Latitude, by 1513, could be measured reasonably well at sea, at least when the skies were clear. You could take the height of the sun at noon, or of the pole star at night with a cross staff or astrolabe, and get your north-south position to within a degree or two. That's why, on many early modern maps, the north-south placement of coasts is not terrible. Longitude was a different story. Without accurate clocks to carry a reference time from a known meridian, there was no easy, reliable way to know how far east or west you'd drifted. Sailors estimated it from dead reckoning, speed times time, and maybe from crude lunar observations, but the errors piled up quickly. On long voyages, your east-west position could be off by hundreds of kilometres. When mapmakers stitched together different voyage reports, each with its own longitude errors, they had to make compromises. They might stretch or compress parts of a coastline to make them meet. They might swing a headland east or west to make two sets of islands line up. Over a whole ocean basin, those little fudges could produce big distortions. Piri himself remarks in the marginal notes that some of his sources disagreed, and that he had to choose which to trust. In the southern Atlantic, where direct Ottoman experience was limited and most information came second-hand, those choices would have had even more room for error. All of this, the stylization, the smoothing, the projection issues, the uncertainties in longitude, creates a kind of cartographic fog. Inside that fog it is very easy to see what you want to see. And yet the coincidence remains. When people tried to align that southern land with Antarctica, they didn't always get nonsense. In some configurations they thought they saw bays where modern charts show bays, peninsulas where we map peninsulas. That was enough to tempt a few researchers into a more systematic test. What happens, they asked, if you take this mysterious southern coastline, assume it represents some real shore and then work backwards? Can you find a projection, a rotation, a scaling that makes it line up with a specific stretch of Antarctic coast better than chance? That question, and the method built around it, would become the core of Charles Hapgood's argument. And it's where the story of the Piri Reis Map leaves the quiet world of parchment and ink and steps into the realm of mathematical reconstructions, US, Air Force endorsements, and decades of debate about whether a good fit on paper is evidence of lost ancient knowledge or just a trick of the lines. Charles Hapgood stepped into that question at a very particular moment in time. It was the 1950s. World War II had just ended. Radar, aerial photography, and the first systematic surveys of polar regions had transformed our understanding of the planet's surface. At the same time, the popular imagination was full of lost civilizations, vanished continents, and the idea that maybe ancient people had known more than we gave them credit for. Hapgood, a history professor with a taste for unorthodox problems, saw in the Piri Reis Map a bridge between those two worlds, a hard physical artifact from 1513 and the tantalizing possibility of forgotten knowledge buried in its lines. He was not a cartographer by training, but he was methodical, and he was stubborn. Where others saw a curious old chart, Hapgood saw data. His first step was to strip the romance away and treat the Piri Reis Map like an object to be measured. He and his students at Keene State College began by cataloguing recognizable features: the Iberian Peninsula, West Africa, the bulge of Brazil. If those matched modern geography reasonably well, he reasoned, then the underlying projection, the way Piri had chosen to flatten the globe, might be recoverable. Hapgood leaned on the tools of historical cartography, as they were understood in his day. He compared the spacing of latitude lines to modern parallels. He traced the compass roses and rhumb lines, looking for patterns that would reveal whether Piri was following a Portolan-style layout, a Ptolemaic grid, or some hybrid. He measured distances between key points in degrees on the map and compared them to actual great circle distances on a globe. From this, he proposed that Piri had not simply drawn a single, coherent projection from scratch. Instead, he argued, the map was a composite, a mosaic built from many older source charts, each drawn on different projections, some perhaps extremely ancient. Piri, in this view, wasn't inventing geography. He was editing it, stitching fragments together and forcing them to coexist on a single piece of parchment. This idea of composite source maps became central to Hapgood's method. If you assume that different regions of the Piri Reis Map come from different original charts, then you have license to treat each region almost as its own puzzle. The West African coast might reflect one projection and one epoch of navigation. The Brazilian shoreline might reflect another, and the mysterious southern land, he thought, might reflect something else again, something that did not fit neatly into the known exploration history of the early 1500s. So Hapgood zoomed in on that southern arc and tried to reverse engineer it. He treated the coastline as if it represented real observations, not speculation. Starting from that assumption, he asked, what kind of projection would turn a polar coastline, say the southern rim of the globe around Antarctica, into the specific curve we see on Piri's map? He experimented with different possibilities: simple cylindrical layouts, conic projections, azimuthal plots centered at various points. Remember, this was pre-computer. Reconstructions that we now do with GIS software and digital globes, Hapgood and his collaborators did by hand, drawing grids, transferring coordinates, rotating tracings on light tables, trying to find a combination of rotation and scale that would turn the southern outline on Piri's parchment into something that looked like a modern Antarctic coast. He eventually landed on a striking claim. If, he said, you treat the Piri Reis southern landmass as part of a spherical projection centered somewhere near Egypt, and then you reproject that region onto a modern polar grid, the fit with Queen Maud Land, the sector of Antarctica facing the South Atlantic, is surprisingly good. In his published work, especially in Maps of the Ancient Sea Kings, 1966, Hapgood reproduced overlays where the sweeping curve of Piri's land appears to echo the arc of Antarctica's coast, including what he interpreted as inlets and bays along the edge. The key twist in his argument was that some of those features, on modern charts, don't correspond to the current ice margin. They correspond to the bedrock coastline underneath the ice, as revealed by seismic and radar sounding in the 20th century. To Hapgood, that was the hook. If Piri's map seemed to know the shape of land buried under kilometres of ice, then maybe Piri's sources had been looking at an Antarctica that wasn't fully ice-covered. From there, the hypothesis became bolder. Hapgood proposed that very ancient, technically sophisticated mariners had charted the Antarctic coast when it was at least partly ice-free, tens of thousands of years ago, perhaps during or before the last glacial maximum. Those charts, he suggested, had been copied and recopied through Greek, possibly even earlier, traditions, eventually finding their way into the library of some unknown navigator whose work Piri inherited through intermediate maps. To explain how Antarctica could have been ice-free in such a recent geological past, Hapgood advanced another idea: crustal displacement. In his model, the entire outer shell of the Earth, the lithosphere, can occasionally slip over the interior, shifting the positions of the poles relative to the continents. If Antarctica had once sat in a milder latitude band, and then been dragged south into the polar deep freeze, an ice-free coastline in remote prehistory could, in principle, be reconciled with present-day conditions. It's important to keep the status of these claims clear. Hapgood's reconstruction of the Piri Reis projection and his suggestion that the southern landmass might correspond to part of Antarctica are hypotheses, attempts to explain a perceived pattern. His broader crustal displacement theory was and remains outside mainstream geophysics, especially after the rise of plate tectonics in the 1960s and 70s, provided a different, well-supported framework for understanding continental motion. Even if you set crustal displacement aside entirely, there's another layer of debate much closer to the map itself. How good is the fit, really? On the page, Hapgood's alignments can look convincing, especially when you're only shown the successful overlay, but methodologically there are several traps here. One is selection bias. Out of all the ways you could line up a distorted early modern coast with modern shorelines, you're more likely to publish the ones that look promising and quietly discard the dozens that don't. If you spend years trying different center points, different rotations, different stretches, you might eventually stumble on an arrangement that seems uncanny, but that doesn't automatically mean the underlying data carries ancient precision. It may reflect the sheer number of attempts you allowed yourself. A second issue is degrees of freedom in the fitting process. Hapgood's reconstructions involve choices: where exactly you place the projection center, how much you rotate the map relative to true north, which segment of the coastline you treat as the match, how you handle scale. Each extra knob you can turn makes it easier to produce a visually appealing overlap, even if the two coastlines are only loosely related. Statistically, that weakens the evidential weight of the match. Then there is the question of what we're matching against. Our modern knowledge of Antarctica's subglacial topography, the rock surface under the ice, has improved dramatically over the last several decades. Early in Hapgood's time, those maps were themselves incomplete and full of interpolation. Different surveys produced different outlines. If you're comparing a fuzzy early 20th century reconstruction of the Antarctic bedrock to a fuzzy 16th century sketch on a distorted projection, measuring accuracy becomes slippery. How far off is too far off? What counts as a meaningful correspondence, as opposed to a coastline that sort of looks right if you squint? These are not trivial concerns. They're the same kinds of problems statisticians worry about when people fit complex models to noisy data. The risk that you're modelling the noise, not the signal. Supporters of Hapgood's work argue that the correspondences he identified go beyond what chance and flexible fitting could produce. Critics counter that once you allow yourself to manipulate projection, centre, and scale, and once you're comparing generalised, smoothed coasts, apparent similarities are almost inevitable. Hapgood himself was aware, at least in part, of these methodological worries. He tried to keep his reasoning explicit to show his working, to marshal the expertise of others where his own training was thin. That's where the US Air Force came in, geographers and cartographic specialists who reviewed some of his reconstructions and, in letters he later published, commented on the apparent quality of the fit. Those endorsements became a crucial piece of the story, cited again and again by people convinced that the Piri Reis Map encodes ancient Antarctic knowledge. But what exactly those experts said, and how strongly it really supports the leap from interesting overlap to lost civilization, is its own puzzle. To untangle that, we have to look at the Air Force connection itself. who was consulted, what they were shown, and how cautious their statements actually were. When people talk about the Piri Reis Map showing Antarctica without ice, the Air Force is almost always in the next sentence. The story usually goes something like this. Hapgood, struggling with projections and coastlines at a small college in New Hampshire, decided he needed serious technical help. So he reached out to professionals, cartographers, geographers, anyone who understood spherical geometry better than he did. Among the people who responded were officers and analysts associated with the US Air Force, particularly at what was then the Strategic Air Command and at the cartographic units that handled global targeting and navigation data during the Cold War. According to the popular retelling, these experts looked at Hapgood's reconstruction of the Piri Reis southern landmass and were stunned. They allegedly confirmed that the fit with Queen Maud Land was remarkably accurate, that the map appeared to show the coastline of Antarctica before it was covered by the ice cap, and that such a thing could only have been made with advanced surveying techniques. In some versions it's implied, sometimes outright stated, that the Air Force essentially validated the idea of an ancient, technologically sophisticated civilization mapping an ice-free Antarctica. Those are strong claims. So what actually happened? Hapgood did receive letters. In Maps of the Ancient Sea Kings, he reproduces excerpts of correspondence from several individuals with military and cartographic backgrounds. One of the most frequently quoted is a letter attributed to Captain Lorenzo W. Burroughs, then chief of a cartographic branch in the Air Force in the 1960s. Burroughs comments that, given Hapgood's assumption that the Piri Reis southern land is Antarctica, and given the projection Hapgood proposes, the agreement between the two is, in his words, unmistakable. That sentence gets repeated everywhere. In books, on websites, in documentaries, you'll see it rendered as, "The Air Force confirmed that the Piri Reis map shows the Queen Maud Land coast of Antarctica ice-free," or "Air Force cartographers certified that the map could only have been drawn before the ice-covered Antarctica." The tone shifts from cautious evaluation to sweeping endorsement. The qualifiers, if we assume, under this projection, within the limits of the data, start to disappear. But if you strip the story back to what these letters actually are, a different picture emerges. When a specialist in a government agency writes to a private researcher about an unusual map, they're not issuing a formal, peer-reviewed judgment on prehistory. They're doing something much narrower. They're looking at the material on the table, the copy of the map they've been sent, the reconstruction the researcher proposes, the modern charts they have access to, and they're offering an opinion on technical questions. Does this curve, under these assumptions, resemble that curve? Is this projection mathematically coherent? Are the distances roughly plausible? That kind of letter is an evaluation, not a stamp of cosmic significance. It's more like a referee saying, "Within the rules you've laid out, your play checks out," than a referee declaring, "Therefore this game changed the history of sports." In the mid-20th century, this kind of expertise mattered more than ever, especially around Antarctica. By the time Hapgood was writing, polar cartography had just gone through a revolution. During and after World War II, the US, the UK, the Soviet Union, and other countries invested heavily in aerial reconnaissance and long-range navigation. Bombers needed accurate Great Circle routes over the poles. Early long-range missiles and later satellites depended on precise geodetic models of Earth. The International Geophysical Year, 1957 to 1958, focused global scientific attention on Antarctica. New surveys, triangulation from the ground, photogrammetry from aircraft, and eventually radar and seismic soundings through the ice, were transforming blank white spaces on maps into real coastlines, mountain ranges, and subglacial basins. Air Force cartographers sat at the heart of that work. They had access to classified and unclassified Antarctic charts that were far ahead of what you'd see in a school atlas. So when Hapgood sent them his overlays, He was, in effect, asking some of the best-informed people on Earth, does this old map segment under this projection look like the Queen Maud Land coast as you currently understand it? If a few of them replied, yes, the similarity is intriguing, that's interesting. It tells us Hapgood's reconstruction wasn't obviously absurd to professionals dealing with real polar data. It means that, at least to those eyes, the southern curve on Piri's map could be made to resemble part of Antarctica if you adopted his projection. What it does not do is prove that Piri's source charts were ancient surveys of an ice-free continent. There's an important distinction here between what a letter literally says and what later writers make it say. Imagine the original wording. Assuming your identification of this landmass as Antarctica is correct, the agreement with Queen Maud Land in this projection is indeed notable, and suggests some degree of geographical knowledge in the source. That's a cautious, conditional statement. A historian might classify it as a professional acknowledging that, given a specific starting hypothesis, the geometry follows. Now compare that to a compressed paraphrase. Air Force experts confirm the Piri Reis Map shows Antarctica accurately. The assumptions are gone, the context is gone. What was once, if A then B seems to follow, quietly becomes B proves A. That's how secondary retellings inflate certainty. You see it in the way quotation marks migrate. A phrase like, the agreement is unmistakable when lifted out of a paragraph full of caveats, becomes a headline. The source, an Air Force cartographer, becomes the US Air Force, as if an entire institution had convened a panel and issued a doctrine on prehistoric seafaring. Authority is signalled by the uniform and the acronym, not by the actual scope of the claim. There's another layer of drift. Hapgood was, understandably, proud that military experts took his work seriously enough to reply. In his books, he uses their letters to bolster his argument. Later authors, sympathetic to his conclusions, sometimes lean harder on those same letters, treating them less as technical commentary and more as external validation of the big story. That Antarctica was mapped in deep time. By the time the tale reaches popular media, nuances of projections, degrees of freedom, and mid-century survey limitations have vanished. What remains is the simplified legend. Even the Air Force agrees. If we want to treat the Piri Reis Map as a genuine historical and scientific puzzle, we need a tighter standard. Strong evidence for an ice-free Antarctica on a 1513 map would look like more than an evocative overlay and a few letters of interest. It would involve clear primary documents, full, unedited copies of all correspondence, with dates, names, positions, and the exact wording of any judgments. Not just one enthusiastic phrase, but the whole chain. What Hapgood sent, what was returned, and how both sides framed the problem. Explicit methods. A transparent description of how the fits were generated, which control points were used, how the projection center was chosen, what transformations were applied, how positional errors were measured. Ideally, this would be laid out well enough that independent researchers could reproduce the process from scratch. Quantitative comparisons, not just it looks good, but numbers. How far off in kilometers or degrees are corresponding capes, bays, or inlets? How does that error compare to other known maps from the same period? What's the baseline we're measuring against? Reproducible outcomes. Multiple analysts working independently with the same data, reaching similar conclusions about the degree of fit, and being able to show that those results are robust, not artifacts of one person's choice of projection or alignment. Cross-corroboration. Ideally, other early maps, unrelated to Piri Reis, that show similar, independently derived Antarctic features under similarly careful analysis. One ambiguous curve might be a fluke. Several, from different traditions, would be harder to dismiss. Right now, we don't have that full package. we have a fascinating 16th century map, a bold mid-20th century reconstruction, some letters from professionals who found parts of that reconstruction worth taking seriously, and a long chain of retellings that sometimes stretch those letters beyond what they actually say. That doesn't make the Air Force connection meaningless. On the contrary, it's part of what keeps the Piri Reis Map interesting. The fact that serious cartographers and military analysts looked at this question at all tells us something. The southern landmass isn't obviously just a scribbled fantasy. It can be made to line up with real geography in ways that, at a minimum, are non-trivial. But interest is not the same as proof. If we keep that distinction clear, the story becomes more grounded and in some ways more compelling. We're left with a quieter, but still intriguing situation. An early 16th century chart contains a southern shape that under certain assumptions can be warped into a partial match with Antarctica. Mid-century experts acknowledged the match within that framework. Later writers turn that acknowledgement into an implied endorsement of ancient ice-free mapping. To go further, we need to look beyond institutional names and reputation. We need to examine the map itself, the arguments for and against the Antarctic identification, and the alternatives proposed by mainstream cartography. That's where we turn next, to the counter-arguments, how professional map historians explain that southern land without invoking lost civilizations or wandering poles, and why they think the Air Force letters don't change the basic story. If you ask a professional map historian what that southern land on the Piri Reis map really is, they usually don't start with Antarctica. They start with something much closer, the tail end of South America. From a mainstream cartographic perspective, the simplest explanation is that Piri's mysterious southern continent is basically a distorted extension of Patagonia and the Tierra del Fuego region, dragged eastward and wrapped around the bottom of the map. Think about what Piri was working with in 1513. By that time, Portuguese and Spanish sailors had pushed far down the coast of South America. Amerigo Vespucci's voyages around 1501 to 1502 had already suggested that this was not Asia, but a huge new landmass with a long south-trending coastline. By 1502, rough sketches showed Brazil and parts of what we now call Argentina extending into high southern latitudes. Later expeditions continued that trend. Every new voyage nudged the known coastline a bit further south, into waters that were colder, rougher, and less well-charted. But they hadn't gone all the way around the bottom yet. No one in Europe had definitively passed through the Strait of Magellan when Piri drew his map. The idea that South America might end in a narrow passage, or perhaps fuse with some larger southern land, was very much in play. Early reports of islands, shoals, and glimpses of land in bad weather got folded into speculation. The result, on many early 16th century charts, is that South America appears to curve, flare, or even merge into a broader southern mass. Mainstream scholars argue that Piri simply did the same thing, but with an Ottoman twist, combining Portuguese charts and rumours into a single continuous coastline. In that reading, the Antarctic shore is really just South America drawn too large, wrapped too far east, and smoothed into a kind of southern fringe. There's another piece that feeds this interpretation, the long history of an imagined southern continent, Terra Australis. Long before anyone had a realistic map of the southern hemisphere, some geographers were convinced there had to be land down there, not because they'd seen it, but because they thought the world needed balance. This goes back at least to classical and medieval ideas about symmetry. If there was a lot of land in the north, some thinkers reasoned, there must be a counterweight in the south, to keep the globe stable and harmonious. Ptolemaic geography, later Arab and European cosmology, and Renaissance speculation all recycled versions of this notion. A vast unknown southern land, Terra Australis Incognita, stretching around the bottom of the world. By the time Piri was compiling his chart, this idea was in the air. Some of the European maps he used as sources probably hinted at, or outright showed a southern continent. Even if their details were vague, the conceptual template was there. Below known coasts, more land. So when you combine three factors, real but incomplete knowledge of South America's southern tip, second-hand reports of land further south, and an inherited expectation that there should be a big southern landmass, it's not surprising that Piri's map ends up with a large, joined-up shape in the south. Mainstream cartographers emphasize that early maps often did this. They fused unknown lands together. Coastlines that were actually fragmented, island-strewn, or simply unexplored got drawn as smooth, continuous curves. A bay glimpsed in fog might be turned into a deep inlet. Two separate islands might be joined by an artist's pen into a single cape. If you only have partial outlines, your brain wants to complete the picture. And if your inherited worldview includes a grand southern continent, completing the picture in that direction feels natural. There's also a matter of aesthetics. Renaissance and early Ottoman world maps aren't just datasheets, they're compositions. Cartographers tried to balance the page visually. If you have a lot of land in the north and an empty white space at the bottom, there's a strong temptation to fill that lower part with something, especially if rumours and cosmological ideas suggest there ought to be land there anyway. A sweeping southern coastline anchors the image, making the map feel complete. From that standpoint, Piri's southern continent doesn't have to come from accurate ancient surveys. It can be seen as a composite. Some real South American coast, some travellers' tales, some guesswork, and a dose of aesthetic symmetry. Then there are the technical objections, where mainstream analysts push back directly on Hapgood's fit with Antarctica. When geographers have tried to reproduce Hapgood's overlays carefully, they run into problems. The scale is off. Certain features that should match in size don't. The distances between supposed corresponding capes or bays don't line up consistently. To make the Piri Reis coastline sit over Queen Maud Land in a satisfying way, you have to stretch and twist the old map quite aggressively. In more technical terms, critics point to discontinuities, segments of the southern coastline that Hapgood wants to treat as one continuous Antarctic shore don't line up with each other in a geometrically clean way. To force them to fit, you have to assume that parts of the original were rotated independently, or that big chunks were displaced relative to one another. The projection centre has to move, or the mapmaker has to have switched reference systems mid-coast without leaving any trace in the way the rest of the world is drawn. For most cartographic historians, this starts to look less like recognizing an original coherent survey, and more like retrofitting. The more degrees of freedom you have to introduce, local rotations here, non-linear scaling there, selective emphasis on some points while ignoring others, the easier it becomes to make almost any wiggly coastline resemble almost any other, at least in outline. And that brings us to a quieter but important point. Resemblance can happen by chance. Coastlines are, in a statistical sense, fractal. They're full of bays, peninsulas, and irregular curves. If you take a random jagged line and scale, rotate and warp it enough, you can often find some configuration where parts of it look strikingly like another random jagged line. Our pattern-hungry brains are very good at noticing those resemblances and very bad at judging how likely they are to occur by accident. Confirmation bias amplifies this tendency. If you start with the desire to see Antarctica in the Piri Reis map, you'll be drawn to every curve that seems to support that idea, and you'll quietly downplay or rationalize the mismatches. A cape that doesn't quite fit can be dismissed as a copying error. A missing bay might be lost in transmission. A whole section that refuses to cooperate can be explained away as damage or as the edge of the original source. From a skeptical perspective, this is how you end up with an unmistakable match that evaporates under more rigorous, blind testing. If you asked several teams without telling them what they were supposed to find, To see which modern coastline best matches Piri's southern land under allowed distortions, some might pick Antarctica, others might pick southern South America, or a composite of both, or conclude that no single fit is compelling. For mainstream cartography, that kind of ambiguity matters. A strong identification should jump out regardless of what you expect to see. If you have to make a long chain of assumptions and adjustments to reach Antarctica, while a simpler, geographically local explanation, it's just an exaggerated Patagonia and Tierra del Fuego, shaded by Terra Australis ideas, requires fewer leaps, the simpler explanation usually wins. That is, in essence, the orthodox stance. The Piri Reis Map is a remarkable artifact, early evidence of how Ottoman scholars engaged with new Atlantic discoveries, a window into the flow of Portuguese and Spanish geographic knowledge, and a testament to the blend of empirical data and inherited cosmology that shaped Renaissance worldviews. But, in the mainstream view, it is not a smoking gun for an ice-free Antarctica mapped thousands of years ago. The southern landmass can be explained, with fewer assumptions, as a distorted, overextended South America fused with speculative Terra Australis. The technical fits to Queen Maud Land are interesting, but not conclusive, and they depend on heavy adjustments that to many specialists look more like imaginative projection than strict analysis. And yet, even within that cautious framework, the resemblance that Hapgood and others highlighted still nags at people. If it's all chance and distortion, why does it feel so suggestive? How do we decide when a visual echo is meaningful and when it's just our brains seeing shapes and clouds? To get at that question, we have to look more closely at how coastlines can seem right for entirely wrong reasons, and how often, in the history of cartography, they have. One of the first traps in all of this is how our brains treat shape. We look at a coastline on an old map, compare it to a modern globe and ask, do they look similar? But that question hides a lot of technical machinery, because what you're really comparing isn't coastlines, it's projections of coastlines. Every flat map of the round earth has to choose how to lie. Take the Mercator projection, the one most of us grew up with in classrooms. Mercator is brilliant for navigation. It keeps compass bearings as straight lines, so a sailor can draw a course and follow a constant heading. But it does that by stretching areas, especially near the poles. Greenland looks enormous. Antarctica, when shown, becomes a smeared white band along the bottom. Shapes get pulled vertically as you move away from the equator. A coastline drawn accurately on a globe will look exaggerated, swollen and distorted on a Mercator chart. Portoland charts, the kind medieval and early Renaissance sailors loved in the Mediterranean, work differently. They're covered in radiating lines that show directions between harbours. They preserve local shapes and distances pretty well in the region they're made for. But they're not true global projections. They're more like carefully tuned local distortions stitched together. Once you move far from the area of real sailing experience, their geometry quietly falls apart. Then you have polar projections, where the mapmaker looks down from the top or bottom of the world. On those, lines of longitude radiate like spokes from the pole. Near that central point, shapes can be rendered with surprising fidelity. Farther away, things stretch and warp along circles. Coastlines curve in weird ways that don't match our usual equator-up mental image. Why does this matter for Piri Reis and Antarctica? Because the more uncertain you are about which projection a map is using, especially a composite map built from many sources, the less straightforward it becomes to say, this outline matches that coast. Change the projection, and you change the apparent shape. Underneath the projection problem, there's something even more basic. The question of where here is. Modern maps rely on a well-defined datum and coordinate system, we can say that a cape lies at 34.6 degrees south, 58.3 degrees west, anchored to a known ellipsoid of the Earth. Pre-modern cartographers didn't have that luxury. They could measure latitude fairly well. If you know where the sun or certain stars sit above the horizon at noon, and you have a decent instrument, you can pin down how far north or south you are to within a small margin. By Piri's time, skilled navigators could routinely estimate latitude to within a degree or two. Longitude was another story. To know how far east or west you are, you have to know the time difference between your location and some reference meridian. That requires accurate timekeeping at sea, which does not become practical until the mid-18th century with the development of marine chronometers. Before that, longitude was a mix of dead reckoning, guesswork, and occasional astronomical methods that were hard to use on a rolling ship. The result is that many early maps are squashed or stretched horizontally. North-south placement might be roughly right, but east-west positions can slide by hundreds of kilometres. Coastlines are bent, twisted, and shifted laterally. Harbours sit too close together or too far apart. Entire peninsulas drift. When you lay a modern coast over a pre-modern one, these uncertainties mean you often have several plausible ways to align them. Shift the old map a bit left or right, or scale it slightly wider, and different parts suddenly seem to match better. Add physical damage and incomplete information, and the door opens even wider. Very few early maps survive in pristine condition. Corners are missing, edges have been trimmed, ink has faded. On the Piri Reis Map, the northern parts are gone. What we have is a large, irregular fragment. The southern coastline we're arguing about is itself interrupted. Segments break off and restart. Some bays are clearly drawn, others are hinted at or simply smoothed away. If you're a cartographer in 1513 working from partial charts, you face the same problem in reverse. You don't have a full coast, you have scattered segments. A bay drawn here, a headland there, a rumour of a strait in between. You have to connect them, so you interpolate. You guess what lies between points A and B. You smooth jagged island chains into curves. You round off peninsulas. You let your pen glide where your data is thin. By the end, you've created something that looks like a coherent shore. But large portions of that line are, in effect, educated imagination. Now fast forward 500 years. We look at that composite guessed-at shoreline and start sliding it around the map of Antarctica, or South America, or some other region. Because it's only loosely constrained, we can rotate it, stretch it, widen or narrow it, and still feel like we haven't broken the original. This is the degrees of freedom problem. The more ways you allow yourself to adjust an old map, change its scale, twist its orientation, bend local sections, assume different projections in different zones, the easier it becomes to manufacture a good fit with something modern. At some point, you're no longer testing whether two shapes independently match. You're tuning one shape until it does. Think of it like fitting a key to a lock. If you're given one rigid key and one fixed lock, either the key works or it doesn't. But if you're allowed to file the key, ream out the lock, change the tumblers, and adjust the angle at which you insert it, you can eventually make almost any key fit almost any lock. With coastlines, that flexibility is multiplied by their fractal nature. Bays within bays, little peninsulas inside larger ones, curves inside curves. Given enough parameters to tweak, our brains will inevitably find parts that seem to echo something we recognize. That doesn't mean old maps were always wildly off. There are impressive counterexamples. The 1450s Framoro map, for instance, gets the general outline of Africa surprisingly close, including the idea that you can sail around its southern tip. Some 14th and 15th century Portolan charts of the Mediterranean nail the positions of harbours to within a few kilometres. Chinese maps from the Ming dynasty place major East Asian coastlines in roughly correct relation to one another. When the projection is understood and the region is well travelled, these charts can line up eerily well with modern data. At the same time, we have maps like the famous 1531 Orontius Phineus world map, where a massive southern continent is drawn with rivers and bays that don't correspond cleanly to any real landmass, or various 16th century maps that show California as an island, or imagine a strait across North America where no such passage exists. Coastlines appear where nothing is there, or fuse regions that are actually separate. In other words, historical cartography gives us both genuine hits and spectacular misses. So how do we tell when a match is meaningful? Cartographers tend to look for a few things. First, independent alignment across multiple features. If a putative match requires you to cherry-pick one nice cape while ignoring 3 neighbouring bays that don't fit at all, that's weak. A strong case is when an entire stretch of coast, its length, its sequence of inlets and headlands, its orientation relative to known reference points, lines up without constant special pleading. Second, consistency under a single, simple transformation. If you can take an old map, apply one reasonable projection assumption, one rotation, one scale adjustment, and then see many features fall into place, that's more persuasive than a fit that demands local warping and piecemeal rotations. Third, convergence from multiple maps. If several independent historical charts, made in different traditions, all show similar accurate details of a region, the odds that they're independently guessing the same wrong shape go down. Shared distortions are suspicious, shared accuracies are informative. Finally, context. Does the historical record support the kind of knowledge the map implies? Are there plausible voyages, instruments, and techniques that could have generated that coastline? Or would accepting the fit require us to posit an otherwise invisible surveying capability that leaves no trace anywhere else? When you apply those criteria, some famous mystery coastlines lose a bit of their shine. Others remain intriguing, not because of a single outline that looks familiar, but because multiple elements line up more cleanly than we'd expect by chance. The southern land on the Piri Reis Map sits right on that boundary. To some eyes, with certain assumptions, parts of it echo Queen Maud land. To others, under a different set of assumptions, it looks more like an overextended South America feathered into Terra Australis. And that ambiguity becomes sharper when we put Piri's map alongside other early visions of the South, because he wasn't the only one drawing a great land at the bottom of the world. Another cartographer, working in France just a few years later, produced an image of a southern continent that would fuel this debate in a very different way. His name was Orontius Phineus, and in 1531 he drew a world that shouldn't quite exist. Unlike Piri Reis, he wasn't a naval commander or a working pilot. He was a French mathematician and cosmographer, the kind of person who lived among books, not rigging. But he was doing something very similar to what Piri had done 18 years earlier, taking bits and pieces of available geography and trying to weld them into a single coherent image of the Earth. The result is a large heart-shaped world map centered on the Atlantic. Europe and Africa sit at the top, the Americas curve down one side, and along the bottom, sweeping from one edge of the known world to the other, is a vast southern continent labelled Terra Australis Recenta Inventa Sed Nondum Plen Cognita. Southern land recently discovered, but not yet fully known. This is the image that would later light up the imaginations of Charles Hapgood and everyone who came after him. Because the southern land on the Orontius Phineus map doesn't just look like a decorative band, the way Antarctica is often drawn on later globes. It looks inhabited, structured, detailed. If you follow its outline with your eyes, you see what people keep coming back to. On the side facing Africa and the Indian Ocean, the coast curves gently, almost like the rim of a giant bowl. On the side facing South America, it juts up into a long peninsula that seems to point toward the Cape of Good Hope. Along the northern edge, there are wide embayments that cut inland, as if great gulfs or seas are gnawing into the continent's interior. Inside that outline, Phineas doesn't leave it blank. He draws rivers, long, sinuous lines running from the interior down to the coasts. Some split and rejoin as if they're tracing real drainage basins. Others terminate exactly where a bay meets the land, the way they do on modern maps. There are mountain symbols scattered along the spine of the continent. There are Latin place names. There are little notations implying capes, promontories and passes. To a modern viewer already primed by the Antarctica debate, it's easy to feel a jolt of recognition. If you mentally erase the ice and imagine Antarctica's true bedrock outline, particularly in reconstructions that show a more connected landmass, with the West Antarctic basins partly emergent, some stretches of Phineas's Southland look uncannily familiar. A bulge here echoes Queen Maud Land. A jagged northern coastline there suggests the Ross Sea or the Weddell Sea. One of the big bays appears, in certain overlays, to line up with the depression under the Ross ice shelf. The idea that you're looking at an ice-free Antarctica sketched centuries before anyone set eyes on the pole suddenly feels less like fantasy and more like a half-remembered memory. That's the pro-mystery reading. It goes like this. Phineas, like Piri Reis, is openly working from older sources. Renaissance mapmakers were constantly scavenging from classical texts, medieval portolans, Arab and Portuguese charts, and whatever rumours came in from the latest voyages. If some of those sources preserved fragments of a far older, more accurate knowledge of the far south, maybe from a seafaring culture we've lost, then Phineas's Terra Australis might not be pure imagination. It could be a dim echo of genuine coastal surveys, distorted by time and copying, but still carrying the underlying shape of a real southern continent. The rivers in this interpretation become especially tantalizing. You don't need rivers on a purely symbolic land. You draw rivers when you think you know something about the interior. On a deglaciated Antarctica, subglacial topography suggests major drainage systems, channeling meltwater from the interior basins to the sea. Hapgood and others looked at those 20th century reconstructions, then back at Phineas's map, and argued that the resemblance was too strong to dismiss as coincidence. But that's only one way of seeing the map. The mainstream reading starts from a different place, the intellectual climate of the early 16th century. By 1531, Europe had circumnavigated the globe. Magellan's expedition had completed its east-west circuit a decade earlier. Sailors and scholars now knew the Earth was finite, measurable, and mostly outlined. But they also carried with them a very old idea, that the world needed balance. Since antiquity, geographers influenced by Ptolemy and others had imagined a terra australis incognita, a huge land in the south that would counterweight the known continents in the north. It wasn't a discovery, it was a hypothesis, almost a metaphysical necessity. If you have so much land up here, there must be something down there, otherwise the sphere would feel wrong. Renaissance compilation maps were built at the intersection of two impulses. One was empirical, plot the coasts that sailors actually reported. The other was theoretical, make the globe look complete and harmonious in light of classical geometry and philosophy. When you reach the edge of reliable information, speculative geography flowed in to fill the blanks. Phineas was steeped in that tradition. We know from his writings and from marginal notes on other works that he was deeply attached to classical authority. He admired Ptolemy. He followed the medieval convention of placing imagined lands where theory said they should be, then clothing them with plausible details. Those rivers cut in across Terra Australis. From this perspective, they're not survey data, they're cartographic decor. Mapmakers commonly peopled unknown interiors with generalized mountain chains, river systems, and invented toponyms. It gave the viewer a sense that the world was known and ordered, even where it wasn't. Very similar river motifs appear on other maps of the period showing Africa's interior, or the northern reaches of Asia, in places where no European had ever set foot. Even the broad outline of Phineus's continent can be read as a collage of borrowed motifs. The eastern curves echo parts of earlier globes by Johannes Schöner, who himself had drawn large speculative southern lands. The hooked peninsula near the Cape can be seen as a kind of mirror to South America, a visual balancing act across the South Atlantic, not a measured coast. Portions of the outline appear to be extended capes or duplicated features from known continents, bent down and fused into a continuous band. In that reading, the similarities to Antarctica in modern reconstructions become a case study in how strongly our pattern-seeking brains want to match things. We take a flexible, speculative outline, overlay it on a reconstructed, partly hypothetical subglacial coast, allow ourselves a few rotations and scale changes, and then feel surprised when we find echoes. But we're comparing one set of uncertainties to another and rewarding ourselves for finding resonance. This is where comparing Phineus to Piri Reis becomes revealing. Piri's surviving fragment focuses on the Atlantic and the western coasts of Africa and South America. It has a gritty, workman-like feel. Place names cluster where sailors actually went. The decorative elements are mostly in the margins. His aim, as far as we can tell, was practical navigation and political briefing. Phineus's map is different. It's global, symmetrical, and self-consciously mathematical. Its projection is a cordiform, heart-shaped design beloved of Renaissance cosmographers for its elegance and connection to classical geometry. It was not meant to guide a ship into harbour. It was meant to show, at a glance, how the world hangs together. Land balancing land, sea balancing sea, the known shading smoothly into the conjectured. Yet both maps end up at the centre of the same argument. In each case, a southern land appears where no formal European discovery had occurred. In each case, later writers look back, slide those shapes against modern images of Antarctica, and ask whether we are seeing something more than guesswork. With Piri, the debate hinges on a broken fragment, and how we choose to interpret its projection. With Phineus, it hinges on how we understand Renaissance cosmology, and the line between data and decoration. One map was born from sailors' logs and captured charts. The other was born from books, globes, and geometry. But together they frame the mystery that keeps resurfacing. Why did so many early modern mapmakers feel so confident drawing a great land at the bottom of the world? To push that question further, we have to leave France and look back toward the eastern Mediterranean. Because while Phineus was drawing his elegant southern continent in Paris, other cartographers under the crescent flag were sketching something just as strange, this time with Arabic script, Ottoman aesthetics, and a very different cartographic tradition. His name, at least as we have it, is Haji Ahmed, and like Piri Reis, he appears in the record through a map that seems to know more than it should. The Haji Ahmed world map is usually dated to around 1559. It's printed, not hand-drawn, and it's produced in Venice, not Istanbul. But the text that accompanies it is in Italian, and it claims to be a translation of a Turkish original compiled by an Ottoman geographer who had drawn the whole world as it is known today. That alone makes it irresistible to people hunting for anomalous cartography. A mysterious Ottoman cartographer, a map straddling the worlds of Islam and Renaissance Italy, and tucked into it, according to some readings, is yet another suggestive glimpse of an Antarctic-like south. To see why it matters, you have to understand the world Haji Ahmed lived in. In the mid-16th century, the Ottoman Empire was an information superhighway. it sat astride trade routes that ran from Lisbon and London through the Mediterranean, across the Middle East, down the Red Sea, and out toward India and East Africa. Pilgrims moved along those routes. So did scholars, sailors, spies, and merchants, and everywhere they went they carried maps, charts, portolans, and written itineraries. Ottoman cartography grew out of that traffic. It wasn't a sealed, inward-looking tradition. It was porous. Translators in Istanbul rendered Portuguese and Italian sailing directions into Ottoman Turkish. Scholars copied Arabic geographical works that had themselves drawn on Greek, Persian, and Indian sources. Captured charts from Venetian or Portuguese ships were absorbed into the imperial archives and reworked. A map like Piri Reis's Atlantic chart is only one snapshot of that process. Haji Ahmed's map is another. The world it shows is recognisably 16th century. Europe and the Mediterranean are fairly accurate. The coasts of Africa follow the Portuguese pattern. The Indian Ocean is outlined in a way that suggests knowledge of both Arab and European voyages. The Americas are there as well, with a long narrow South America and a more blocky North America fused in ambiguous ways to Asia. Still a common confusion at the time, and then there's the South. Along the bottom of the map, forming a kind of scalloped fringe beneath the Indian Ocean and the Pacific, is a large landmass. It is not labelled Terra Australis in Latin. The inscriptions are in Italian, giving brief descriptions of regions and seas, but the shape is familiar enough to have caught the attention of anomalous map writers. On the southwestern side, under Africa, you see a broad, rounded projection. Under the Indian Ocean, the coast bends and dips, like the edge of a broken plate. Further east, below the Pacific, the outline draws back northward and then ends, as if the land is curving up toward what we would now call Australia. When proponents of the ancient Antarctic maps hypothesis look at this, they do something similar to what they do with Orontius Phineus. They mentally strip away the decorative scalloping, stretch and warp the outline, and compare it to an ice-free reconstruction of East Antarctica, the coast of Queen Maud Land, the indentation around the Princess Astrid coast, the jut of Wilkes Land underneath the Indian Ocean. If you let your imagination lock onto those correspondences, the resemblance feels like a clue. Here again, in a document claiming to translate Ottoman knowledge, is a southern land in roughly the right place, with roughly the right gestures of coastline. To them, that starts to look like a pattern. Ottomans like Piri Reis and Haji Ahmed working with older, perhaps non-European charts. Those charts preserving fragments of pre-glacial surveying, and all that knowledge reappearing, faint but persistent, in printed form. That's one story you can tell. But before you follow it too far, it's worth asking what we actually know about this map. For one thing, the Haji Ahmed we're talking about is partly a construct of the Venetian printing house. The Italian text on the map refers to Haji Ahmed as a Turk who'd converted to Christianity and settled in Italy. Some scholars suspect that what we have is an Italian engraver working from one or more Ottoman-style charts, plus oral or written explanations from an informant, and then packaging the result as an exotic Turkish view of the world for a European audience hungry for novelty. The original Turkish manuscript, if it existed as a unified map, is lost. We have the printed sheet. We have its Italian explanatory text. We have stylistic clues that point to multiple sources. Some coastlines clearly derived from Portuguese or Italian models, others perhaps from Islamic charts, still others adapted from Ptolemaic tradition. In other words, the provenance is complicated. This isn't a pure Ottoman artifact. It's a hybrid object born at the intersection of Ottoman geography and Venetian publishing. And that matters, because it means the southern land we're staring at is part of a shared visual vocabulary, not a solitary revelation. By the 1550s, drawing a great southern continent was almost a reflex among cosmographers, no matter which language they wrote in. Portuguese-influenced maps showed a southland. French and German globes showed a southland. Schooner, Phineas, Mercator, they all did it. The form varied, but the trope was the same. Balance the globe, fill the blank, connect rumoured coasts into something continuous. The Haji Ahmed map follows that habit closely. Look at how the southern land is drawn compared to the rest of the sheet. The lines are smooth, generalised, almost ornamental. There are no dense clusters of place names hugging the coast the way they do around the Mediterranean or the Red Sea. There are no little promontories labelled with specific ports. Instead, the land acts like a decorative border, echoing the roundness of the map itself. This is a telling detail. In early modern mapping, density of text often tracks density of knowledge. Where pilots had sailed and merchants had traded, names pile up. Where no one had gone, the names thin out, and the coastlines become more like frames than surveys. You see the same aesthetic elsewhere on the Haji Ahmed map. The margins bristle with compass roses, wind heads, and ornamental scrolls. Mountain chains are sketched in simple, repeated motifs, not in detailed topographic profiles. Rivers meander decoratively, and sometimes impossibly to fill interior space. None of that is a flaw, it's just how maps of that type worked. They were meant to convey a combination of information, prestige, and world view. So when we compare its southern fringe to modern Antarctica, we're doing something a bit unfair. We're taking a generalised, trope-driven form and lining it up against a very specific, data-heavy outline. Any resemblance we find lives at the level of gesture, not of measurement. This is where the Ottoman context becomes especially useful as a reality check. Ottoman cartographers were as capable as their European contemporaries of compiling data from multiple voyages. They were also perfectly comfortable grafting classical and Islamic cosmological ideas onto that data. Piri Reis himself does this. Portions of his coastlines are hard-nosed Portolan work. Other parts are mythic islands and sea creatures. The same mixture appears in later Ottoman atlases like the Kitab-ul-Bahriyeh. Haji Ahmed's map fits that blended tradition. Some of its features are clearly empirical, rooted in reports from Indian Ocean pilots and Mediterranean sailors. Others are theoretical, a wide southern land, a still vague connection between the Americas and Asia, interior rivers that mirror older Arabic and Ptolemaic schemes. The lesson hiding in all of this is simple but easy to forget. A compelling shape on a 16th century map does not automatically imply that someone, somewhere, had walked or sailed that coast with an instrument in hand. It might just mean that the mapmaker was very good at making the unknown look plausible. The Haji Ahmed map shows us an Ottoman Venetian world that was hungry to synthesize every scrap of knowledge it could get, but still deeply attached to inherited ideas about how the earth should look. Its southern land is part of that synthesis, not clean evidence of ice-free surveying, and yet, even as we recognise that, the image still pulls at us. It reminds us how delicate the line is between data and decoration, between what a mapmaker really knew and what he only felt should be there. That tension becomes crucial when we turn to the 18th century, and to a French geographer who claimed to show not just a southern continent, but the hidden shape of the land buried under its ice. His name is Philippe Boitier, and he belongs to a very different world from Piri Reis or Haji Ahmed. Boitier is working in Paris in the mid-1700s, not in a port city covered in salt spray and tar, but in drawing rooms and academies. He's a royal geographer to the King of France, a member of the Académie des Sciences, and a specialist in what his contemporaries call theoretical geography. That phrase matters. Boitier is not primarily a collector of sailors' charts. He's a model builder. He thinks the earth has an underlying order, a hidden structure you can infer from principles, not just from voyages. Oceans should have deep troughs to carry currents. Continents should have mountain chains that guide rivers. Polar regions should be shaped in ways that balance the globe. So when he draws a southern continent, he's not just copying what captains report. He's trying to deduce what must be there. The map that gets him into the Antarctica mystery is usually dated to the late 1730s and 1740s in various versions. In it, Boittier shows a large southern land, but it's not one continuous blob. Instead, he splits it into two main masses with gulfs and channels running between them. One mass on the side facing the Atlantic and Indian Oceans, another mass more toward the Pacific. Between them, a kind of polar sea. To readers steeped in modern satellite imagery, that division sounds familiar. Today we know that Antarctica is geologically composed of two main regions: East Antarctica, the huge higher elevation block, and West Antarctica, lower and more fragmented with deep basins and rift systems. Under the ice, modern surveys have revealed a complex landscape of mountain ranges, plateaus and depressions filled with subglacial water and sediment. In some reconstructions, especially those emphasizing subglacial basins and isostatically rebounded shorelines, the outline of an ice-reduced Antarctica can look like two major landmasses knitted together by ice and low-lying channels. If you take Boittier's map, strip away the decorative elements, and tilt and scale it just right, you can convince yourself that he has drawn something very similar. Two Antarcticas with straits between them. That's why he keeps showing up in books and documentaries about ancient Antarctic maps. Authors like Charles Hapgood point to Boittier and say, "Look, here is an 18th century geographer who seems to know that Antarctica isn't a single smooth land, but a broken channeled structure." And, they argue, Boittier claimed he based at least part of his southern vision on older sources, even older than Magellan or Cook. So what did Boittier actually know? And what could anyone in 1740 reasonably infer about a continent almost no one had seen? By the early 18th century, Antarctica as a name and concept was in circulation, but the land itself was still almost completely hypothetical. Sailors in high southern latitudes had met ice, storms and fog. They had not met a clear coastline they could trace around. Cook wouldn't cross the Antarctic Circle until the 1770s, and even he never sighted the continental shore. Instead, geographers had fragments, reports of ice islands drifting north, strange currents, temperatures dropping far below what latitude alone would suggest, occasional sightings of land or pack ice that might conceal land. On top of that, they had centuries of inherited doctrine insisting there ought to be a great southern land to balance the northern continents and stabilize the globe. Boittier took all of that and tried to impose order on it. He was fascinated by ocean currents. The Gulf Stream in the Atlantic, the circulation of waters around Cape Horn and the Cape of Good Hope, the flow of cold water northward in the Pacific. To him, currents weren't just surface phenomena. They were guided by deep submarine valleys and basins, the skeleton of the world's oceans. If cold water is moving in a certain way, he thought, there must be a channel. If icebergs are drifting along particular tracks, there must be a submerged strait helping them. If the winds behave one way in the South Atlantic and another in the South Pacific, something in the land-water layout has to be steering them. From those premises, he hypothesized that the southern polar region couldn't be a single, solid, round lump of land. It needed openings to allow water to circulate around the pole, so in his famous map he reveals a kind of polar Mediterranean, a sea encircled by land but pierced by straits, allowing exchange with the Atlantic, Indian and Pacific Oceans. The two large land masses on either side are, in his mind, not measured continents, but theoretical buttresses holding that system in place. Later, when we discovered the complicated bathymetry around Antarctica, the Drake Passage, the deep seas under the Ross and Weddell ice shelves, and the West Antarctic Rift System, it became tempting to retrofit Boittier's speculative channels onto our modern maps. To say, he was right about there being broken land, right about there being polar seas, write about there being gulfs in Antarctica. The danger in that kind of back projection is subtle. Whenever we gain new knowledge, we can't help but look backward for precursors. We search older texts and images for hints that someone had anticipated what we now see clearly, and sometimes they have. There really are cases where a scientist or thinker was extraordinarily prescient, sketching a future discovery with eerie accuracy. But more often, what's happening is this. Past thinkers produced a wide variety of guesses, models, and mental pictures. Some of those guesses, by sheer chance or by broad brush reasoning, overlap with later findings. We then focus our attention on the hits and forget all the misses. Boakye drew many maps, not just the one that seems suggestive. He also proposed speculative sea routes through a northwest passage that doesn't exist in the way he imagined. He sketched interior river systems in North America that do not match what surveys eventually found. His understanding of the Pacific was reasonably good in some places and wildly off in others. When you zoom in only on the southern polar region, he looks like a prophet. When you zoom out to his whole body of work, he looks like what he was, a clever, systematic guesser operating with limited data and strong theoretical commitments. Mainstream historians and cartographers tend to explain his Antarctic configuration in those terms. First, theoretical geography. Boakye explicitly described himself as reconstructing the ancien état of the Earth, the ancient state, using reason as much as observation. If his system said the polar seas needed outlets, he would draw them, even if no ship had ever sailed them. Second, symmetry arguments. The idea that continents and oceans should be balanced isn't just a Renaissance quirk. It lingers into the Enlightenment. If there are multiple land masses in the north broken by seas, it feels natural in that mindset to expect similar broken structures in the south. Paired capes, mirrored gulfs, archipelagos rhyming across hemispheres. Third, extrapolation from currents and ice drift. It was a genuinely insightful move to treat currents as clues to unseen geography. Boakye wasn't wrong that underwater topography shapes circulation. He was just filling in far more detail than the data could justify, stretching plausible inference into elaborate cartographic flesh. From this perspective, his two Antarcticas aren't traces of a lost ice-free survey. They are the imprint of his intellectual style, taking fragments, currents, temperature anomalies, iceberg paths, and amplifying them into a complete polar architecture. And yet, if you're sympathetic to the idea that some very old knowledge might have trickled down in distorted forms, Boakye remains a tempting figure. Did he, as Hapgood suggested, perhaps have access to older charts, Greek, Phoenician or otherwise, that influenced his sense of a channeled south? Or was he doing, at a high academic level, the same thing Orontius Phineas and Haji Ahmed had done before him, inheriting a vague southern something and reshaping it to fit his worldview? Before we try to answer that, this is a good moment to mention something we've been working on outside of this video. If you like falling asleep to deep dives like this one, the channel's book is out now at sleepytimehistory.com, and there's a discount running this week. It gathers stories just like this. Real documents, strange patterns, and the quiet puzzles they leave behind. Back in the world of maps, the harder question isn't whether Boakye individually was psychic about Antarctica. It's whether the pattern across multiple maps means anything beyond shared habits of speculation. Piri Reis hinting at a southern shore, Orontius Phineas wrapping a southland around the pole, Haji Ahmed fringed with a scalloped austral continent, Boakye splitting the south into two. Do these add up to independent echoes of some underlying ancient survey of an ice-free Antarctica? Or are they variations on a single inherited motif, Terra Australis, filtered through different cultures and centuries? If all the southern continents in these maps ultimately trace back to the same bundle of classical and medieval ideas, then their similarities don't require any lost civilization. They just tell us that cartographers, from Istanbul to Paris, were working off the same mental template of how the globe should be completed. If, on the other hand, you could show that some specific feature, some bay, some mountain chain, some channel, appears correctly in multiple maps that don't share a clear line of copying and that couldn't easily have been guessed from currents or symmetry, then the argument gets more interesting. That is the line of thought that leads people like Hapgood to talk about pre-glacial surveys and older sources behind Renaissance and Enlightenment charts. It's also the line that makes most professional cartographers uncomfortable, because the burden of proof for such a claim is extremely high. To see how high, it helps to ask a practical question. If someone really had mapped Antarctica without its ice, what would it have taken? What kind of survey, with what kind of instruments, over what time frame, and would the maps they produced look anything like the speculative southern continents we've been staring at? That's where we turn next. To get a sense of what would really be required, start with something simple. What does it mean for a coastline to be accurate on a map? It's not just about drawing a squiggly line that vaguely hugs the edge of land and sea. It's about relationships. Where does this bay sit relative to that headland? How far is it from this cape to that island? If you sail due west from one point, what angle do you have to turn to hit the next? Any reasonably accurate coastal chart has to capture three things at once. First, repeated observations. You don't just pass a coast once in fog and call it done. You hug the shore on different days, at different tides, marking how the land looks from different bearings. You correct your earlier notes when you realise a peninsula is really an island, or that two bays are actually one big embayment. Second, distances. You need some way of turning days at sea into lengths on paper. In the age of sail, that meant estimating speed and time, dead reckoning. Or later, more precise log lines and watches. Even crude methods let you say, roughly, from this cape we sailed southeast for 2 days at 6 knots. Third, a consistent frame of reference. That usually means latitude and longitude. Latitude, the north-south position, is relatively easy with basic tools and a clear sky. You measure the height of the sun at noon, or the angle to known stars. Longitude, the east-west position, is notoriously hard without precise timekeeping. For a long time, cartographers were essentially stretching and compressing coasts east-west like elastic bands because they didn't know exactly how far around the world they'd gone. Put those together and you have the skeleton of a modern-style chart. Bearings, distances, and coordinates, all tied into a single grid. The more observations and the more cross-checks from different voyages, the better the map. Now imagine trying to do that not along the coast of, say, Portugal, but around an ice-free Antarctica. Even if we generously set aside the ice and pretend the rock outline is naked, the environment itself is a nightmare. The weather is brutal. Storm systems circle the pole in what sailors call the roaring 40s, furious 50s, and screaming 60s. Winds shift fast. Visibility can collapse from clear to white out in minutes. Sea states are violent. The same currents that later explorers struggled with would be battering any hypothetical ancient mariners too. Sea ice doesn't just vanish because the main ice sheet is gone. Seasonal ice would still form and break up. Pack ice would drift with wind and current, sometimes masking the shore, sometimes mimicking it. A line of grounded ice or low ice shelves along a shallow coast can look a lot like land if you don't get close enough, or if getting close enough is too dangerous. Seasonal access is another problem. At high southern latitudes, winter is essentially 6 months of darkness and worsening ice. Even in summer, the window of relatively safe exploration is limited. To trace a full coastline, you'd likely need multiple seasons, maybe multiple generations of voyaging, stitching together partial segments observed under varying conditions. And then there's navigation. What could a clever but pre-modern seafaring culture realistically do? Stellar navigation has been around in some form for a very long time. Polynesian navigators, Phoenician traders, Arab pilots in the Indian Ocean all use stars, sun, swell patterns, winds, and even bird behaviour to cross open water. With simple instruments, or even just trained eyes and memory, you can estimate latitude quite well. Many ancient and medieval sailors did. Whether they formalised it in degrees or not, dead reckoning, the practice of tracking your course and speed over time, is also ancient. You start from a known point, keep track of your heading by the stars or a primitive compass, estimate how fast you're moving, and update your position mentally or on a chart. It accumulates errors quickly, but it's better than nothing. What you do not have before accurate mechanical clocks and a shared global reference is precise longitude. That means you can know, more or less, how far south you've gone, but not exactly how far around the world you are. So an ancient or even medieval mariner could, in principle, recognise that a certain coast lies at, say, the latitude of 60 degrees south. They might even be able to estimate how long it takes to sail from one point on that coast to another. But tying that to a global system, saying this bay is here on the planet relative to Africa, South America and Australia, is extraordinarily difficult. That's why early modern European maps are often pretty good north-south and much more distorted east-west. It's not because they'd never seen those places, it's because the mathematics and instrumentation for longitude were missing. So if you imagine some earlier culture mapping an ice-free Antarctica with anything like the precision suggested by modern enthusiasts, you have to grant them either an astonishingly advanced observational program over centuries or tools that functionally solve the longitude problem. Mainstream historians are reluctant to do either without independent evidence. A more conservative way to read the puzzle is to step down a level. Maybe we're not dealing with a full, accurate survey of a continent. Maybe we're dealing with scraps and glimpses, a partial coastline seen under unusually favourable ice conditions, an especially bad melt season exposing rocky islands along a shelf, a few promontories jutting beyond the usual ice line, or even something more mundane, sections of the far South Atlantic and South Indian Ocean coasts, Patagonia, Tierra del Fuego, the Falklands, the Kerguelen Islands, blurred and misprojected into a kind of pseudo-Antarctic mass. Cartographers working in Istanbul or Paris might then inherit reports like, "Far to the south there is broken land with fjords and ice. Combined with the expectation of a southern land, those fragments could harden into shapes on a map." It doesn't require an entire loss survey, just a few ambiguous encounters magnified by imagination and theory. From there, you can extend the spectrum. On the bolder end, people like Hapgood suggest that somewhere, sometime before our current historical horizon, there were organised efforts to chart high southern latitudes more systematically. Not a global, satellite-like survey, but maybe dedicated seafaring routes that skimmed along an exposed Antarctic coast during warmer intervals. The charts produced, fragile and few, could have been copied and recopied, degraded and translated, ending up in ancient libraries, Alexandria, Pergamon, Constantinople, and then, after losses and wars, in the hands of Renaissance and Ottoman mapmakers in fragmentary form. In that picture, no single map we have is the ancient original. Instead, Piri Reis, Orontius Phineas, Haji Ahmed, Bouache and others would each be holding different threads of a tattered archive. Each tries to reconcile those threads with the best knowledge of their own time. Coastlines get stretched to fit new projections, mountains become decorative flourishes, gaps are filled in by guesswork. What began as a reasonably careful coastal sketch could, over centuries, morph into something only vaguely reminiscent of the original, yet still retaining a few anchor points that happen to align with modern data. Mainstream scholarship does not endorse that reconstruction. There is, as of now, no hard evidence for such a deep, technical cartographic tradition. No instruments, no shipwrecks clearly out of place, no unambiguous references in surviving texts. But as a hypothesis about how knowledge might move and mutate, if it existed, it's internally coherent. It doesn't require aliens or magic, just more continuity in human seafaring than we currently think we can prove. And that leads to a quieter, perhaps more interesting implication. Maybe the real mystery around these Antarctic-looking maps is less about who first discovered the southern continent, and more about how information survives at all. How a sailor's impression can become a portolan chart, how that chart becomes a decorative globe, how a theoretical geographer's model gets mistaken for a memory of some vanished survey. In other words, when we stare at the southern margins of the Piri Reis Map or the split land of Boachi's Antarctica, we might not just be asking, did someone map this place long ago? We might be asking, what happens to knowledge as it's copied, translated, theorized, and half-remembered over centuries? That's the question that hangs over the final part of this story, not just what these maps show, but what they tell us about the strange afterlives of forgotten information. If you zoom out, the Piri Reis Map and its Antarctic cousins start to look less like smoking guns and more like stress tests for a bigger question. How hard is it really for technical knowledge to vanish? You don't have to leap all the way to the Silurian hypothesis, the idea that an earlier industrial civilization could have risen and fallen in deep time, leaving only ambiguous traces in the geological record to feel the edge of that question. You just have to think about how fragile information is even over a few thousand years. Paper burns, parchment molds, ink fades. Libraries rely on roofs not leaking, on cities not being sacked, on one king deciding not to repurpose the shelves for something else. And the more specialized the knowledge, the more fragile it tends to be. A story can survive in songs and myths, passed from grandmother to grandchild with no tools at all. There was a flood. There was a mountain. The sea rose. Versions of that echo around the world because they can live in memory and performance. But a careful coastal survey, bearings, distances, notes on prevailing winds and shoals, that doesn't compress into a campfire tale very well. It lives in logbooks and charts. It needs paper, ink, specialist training. If the chain of copying breaks for a few generations, the knowledge evaporates. That's all you need to make Piri Reis-style mysteries at least psychologically plausible. You don't have to assume a vanished super-civilization. You just have to accept that thin technical traditions are easier to erase than we might like to think. Now scale that up to the level of empires. For most of history, long-distance knowledge has moved through three main conduits: libraries, states, and trade networks. Each one preserves information, and each one also distorts it. A merchant in Aden hears from a sailor who claims to have seen icebergs far to the south. The merchant repeats it to a Venetian factor. The Venetian writes to a cartographer in Florence. By the time it shows up in a marginal note on a portolan chart, ice in the southern sea might have become frozen shores, or land of cold. The original observation, a foggy glimpse of pack ice on the horizon, has been filtered through 3 languages, 4 agendas, and a couple of guesses. Multiply that by centuries. Imperial capitals act as reservoirs. The Ptolemies in Alexandria collected scrolls from every ship that entered their harbour. The Abbasid caliphs sponsored translations in Baghdad. The Byzantines hoarded classical texts in Constantinople. The Ottomans inherited some of that. Each regime mixed empirical reports with theoretical models. Greek geographers believed in a balancing southern continent for climatic symmetry. Medieval Islamic scholars preserved and debated those texts. Renaissance Europeans absorbed that whole lineage and grafted it onto their own voyages. When a mapmaker like Piri Reis or Orontius Phineas set pen to parchment, they were not starting from scratch. They were standing at the end of long chains of copying and commentary, reports from sailors, numbers from astronomers, speculations from philosophers, all layered, corrected, and sometimes just pasted side by side. That's a powerful way to move information across time. It's also a great way to generate convincing illusions. A map can look anciently wise because it's the product of centuries of synthesis, not because it's preserving some single, pristine insight from a forgotten survey. This is where frustration often creeps in for people who find the Antarctica question compelling. You'll hear a familiar refrain: mainstream archaeology refuses to engage. Part of that is perception. Academic work moves slowly. It's written in specialized language. A sober article that spends 20 pages analyzing the script style on a 16th century chart doesn't feel, from the outside, like it's grappling with the real mystery. It feels like it's sidestepping. There are also incentives. Careers are built on publishable, defensible claims. If you hang your reputation on a radical reinterpretation of a famous map and it collapses under scrutiny, you pay the price. That doesn't mean scholars never take risks. It means they take them where they think the evidence can carry the weight. And the evidence bar is high by design. Archaeology and historical cartography are empirical fields. They're built on provenance, where an object came from, how it's dated, what else was found with it. They rely on reproducible methods, cross-checking inks, comparing handwriting, tracking changes across multiple copies. From that perspective, something like this 16th century coastline might match a hypothetical deglaciated Antarctica isn't a small interpretive tweak. It's an extraordinary claim. It implies either deep continuity of seafaring far beyond our current record, or unexplained observational capabilities in the relatively recent past. To take that seriously, academics would need more than a suggestive outline. They'd need an entire scaffold of supporting data. At the same time, it's not accurate to say that scholars simply ignore these puzzles. Historians of science have written on Hapgood. Cartographic historians have analysed the Piri Reis Map, the Orontius Phineas Map, Boache Haji Ahmed. They may not reach the conclusions enthusiasts hope for, but the engagement is there, buried in journals and conference proceedings rather than YouTube thumbnails. So the fair middle looks something like this. Yes, people with relevant expertise do study these maps. Yes, they are open, at least in principle, to revising timelines when new, solid evidence appears. But they also insist that extraordinary interpretations require extraordinary documentation, not just pattern recognition, not just, this looks kind of similar if you squint, concrete, testable links. If you're curious where real progress could come from, it's less glamorous than lost civilizations, but more powerful, better provenance work. Tracing each surviving copy of a map back through archives, wills and catalogues to see exactly when and where it entered the historical record. High-resolution scans that let researchers examine layer by layer, underdrawings, corrections, additions in different inks. Sometimes you can literally see a cartographer change their mind. Chemical analysis of inks and pigments. These can date when particular parts of a map were added, or show that a suspicious ancient coastline was drawn with a pigment not used until centuries later. More rigorous cartographic fitting. Instead of eyeballing resemblances, you define control points, apply known projections, and quantify how well a supposed match actually lines up. If a southern landmass on a 16th century map really encodes subglacial Antarctic features, it should be possible to demonstrate that consistently and reproducibly, not just in cherry-picked segments. And crucially, better integration between fields. Glaciologists, oceanographers, historians, and geodesists talking to each other, checking each other's assumptions. If someone claims that a particular fjord would have been ice-free at a given time, that's something a climate model can in principle weigh in on. All of that is slow, meticulous, sometimes boring. But it's how ambiguous curiosities become solid knowledge, or are quietly retired as coincidences. Which brings us back to the lingering unease. When you look at the Piri Reis Map, or the southern continent of Orontius Phineus, or Boachi's split Antarctica, you're confronted with a choice about where to put the weirdness. Is it in the world, that is, in the possibility that someone, sometime, really did see more of the far south than our current histories allow? Or is it in us, in the way humans inherit, compress, and recombine fragments of information until they resemble something more coherent than they really are? Maybe the southern coasts on those maps are distant memories of land beyond the storm belts. Maybe they're the shadows of theoretical continents that never existed. Maybe they're careful observations of places we already know, stretched and twisted by bad projections and centuries of copying. Right now, we don't have to decide. We can hold the tension. We can admit that knowledge is more fragile than we assume, that libraries and empires are not permanent, that specialized skills can vanish in a single bad century. We can also admit that our pattern-seeking brains are very good at turning noise into signal, coincidence into story. The final question, then, may not be, who first mapped Antarctica without ice? It may be something subtler. When we see a familiar shape emerging from the tangle of old charts and lost reports, are we rediscovering a forgotten observation, or watching ourselves once again draw meaning into the blank spaces of our own maps? So where does that leave us at the end of this long walk through old parchment and ice? We're left with something that doesn't quite resolve, and maybe that's the point. On one side of the scale there are the pieces that make the Piri Reis Map feel like a genuine puzzle. The artifact is real. It's dated, signed, and anchored in a known historical context. 1513, in the courtly cosmopolitan world of the early Ottoman Empire. It's not a forgery that appeared in the age of clickbait. It was rediscovered in 1929, bricked up in a wall of the Topkapi Palace. On that surviving fragment, the southern part of the Atlantic is drawn with a confidence that seems at first glance ahead of its time. You have a suggestion of a continuous land mass curling under the cape. You have rivers and inlets sketched along its edge. You have Piri Reis himself writing in the margins that some of his information comes from ancient maps, no longer extant. And this isn't in isolation. 16th century Europe is suddenly peopled with charts that show a substantial southern continent, while actual exploration of the far south is still in its infancy. Orontius Phineus draws a ring of land around the pole in 1531. Haji Ahmed's world map hints at strange southern extensions. Boache, a couple of centuries later, slices Antarctica into separated land masses with internal seas, in a way that happens to echo some modern subglacial reconstructions. If you line those up in your mind, one after another, it's hard not to feel like something is peeking through. Real documents, real draftsmen, recurring images of a southern continent long before Cook, long before Ross, long before anyone we know about was carefully sounding the pack ice. On the other side of the scale, the skeptical case is equally real and equally grounded. No one disputes that early modern mapmakers struggled with projections. When you try to flatten a curved earth onto parchment, you have choices to make about where to stretch and where to compress. Piri's fragment is a Portolan-style chart stitched to pieces that seem to use a different geometric logic. Coastlines can slide, rotate, and fuse just from the way you choose your reference lines. Terra Australis wasn't a fringe idea. It was mainstream cosmology for well over 1,000 years. From Ptolemy onward, scholars expected a southern land to balance the northern continents for reasons of symmetry and climate theory. When Orontius Phineus draws a detailed southern continent, he is as much illustrating a hypothesis as plotting a survey. And then there's us, the way our pattern-hungry minds work. We're very good at taking something approximate and seeing in it what we want to see. An irregular shoreline becomes this bay, that peninsula. A kink in a line becomes this fjord, that ice shelf. If you are allowed to rotate, stretch, and selectively ignore the parts that don't fit, you can make a surprising number of old coastlines match whatever modern outline you happen to be thinking about. Those are not trivial objections. They don't wave the mystery away. They just remind us that if we want to claim extraordinary continuity of forgotten knowledge, we have to first exhaust the ordinary ways that shapes can deceive us. Which brings us to the narrow, honest middle. We have a real 16th century map, drawn by a real Ottoman admiral with access to an unusually rich mixture of sources. On its southern edge, we see land whose identity is not straightforward. Is it a distorted extension of South America, pulled too far east and south by projection errors and the attempt to fit multiple source charts onto one sheet? Is it a speculative terra australis, an artist's rendition of what should be there according to ancient geographical theory, decorated with a few details borrowed from travellers' tales? Is it, at least in part, a distant memory of actual voyages further south than the standard record allows, fishermen, sealers, or whalers edging into high southern latitudes and reporting land where we'd now say ice shelf? Or is it some messy combination of all three? Bits of genuine observation woven into a tapestry of inherited theory and creative cartography. Right now, with the evidence we have, we can't push that question to a crisp answer. We can describe possibilities, weigh likelihoods, test fits numerically, and argue about which coincidences count. What we can't do is stand up and say, with the kind of certainty science demands, this is absolutely Antarctica without ice, or this is absolutely nothing but fantasy. So the question I think is worth holding on to isn't a slogan, but a sentence. What exactly is the southern land on the Piri Reis fragment? Not in the sense of what we feel it is, or what we'd like it to be, but what we can eventually show with slow, careful work across archives and disciplines. Until that day, if it ever comes, we're in the quiet space of an open problem, and that can be a good place to rest. Because how we respond to that ambiguity says something about us. Do we rush to the most dramatic explanation? Do we refuse to consider anything that isn't already in the textbooks? Or can we sit in the middle for a while, letting the documents, the ice cores, the climate models, and the old ink have their say without forcing them to agree too soon? As you drift towards sleep, or toward your next thought, I'd like to hand that question over to you. Where are you listening from right now, and what time is it there? Are you in a city lit by midnight neon, on a quiet farm before dawn, in a dorm room halfway between lectures? And from that place on the map, looking at this other map in your mind, which explanation feels most plausible to you at this moment? Is Piri's southern land mostly projection errors and inherited terra australis? A faint echo of real southern voyages? Something stranger we haven't quite framed correctly yet? There's no quiz at the end, just a chance to notice where your own sense of possibility lives. If you'd like to share, I'd love to hear your thoughts in the comments. Where you are, what time it is, and which reading of the Piri Reis puzzle you find yourself leaning toward after this journey. If this kind of calm, curiosity-driven exploration helps you unwind, it really does make a difference if you tap like, leave a comment, and subscribe. It tells the algorithms there are people who want long, slow dives into old mysteries instead of just quick shocks. And if you want to keep wandering through the deeper layers of prehistory, the bottlenecks, the lost skills, the things we might have known and forgotten, I've put a lot more of that into a book about prehistoric secrets and the deep past. You can read more about it and pick up a copy if you'd like at sleepytimehistory.com. For now, we can leave Piri Reis's fragment where it has been for 500 years, a small, stubborn question mark at the edge of the known world, a reminder that even in an age of satellites and laser altimeters, there are still places, on maps, in history and in ourselves, where the lines blur and the answers stay just out of reach,